మాట్లాడరు కొట్టిండారా
ಇದು ಕಾಣಿಸ್ತಿಲ್ವಲ್ಲ, ಯು ಆರ್ ನಾಟ್ ಅಲೌಡ್ ಟು ಟರ್ನ್ ಆನ್ ದ ಕ್ಯಾಮ್ರಾ. ಓ, ಅಂದ್ರೆ ಅವ್ರು ಅರ್ಥ ಮಾಡಲ್ವಾ?
Hello, good evening. Am I audible?
Yeah, Arpita, audible for
Yes,
us.
you are audible. Yes.
Yeah, thank you, sir. Good evening, sir.
Good evening, madam. Namaskara, sir.
Sir, namaste. Namaste.
Madam, ಶುರು ಮಾಡ್ಬೋದಾ?
We'll start in another 2 minutes, sir. We'll start, sir.
मैडम म्यूट ऑल कीजिएगा प्लीज, इट इज क्रिएटिंग नॉइज.
Sir, shall we start? Shiv Kumar, sir. Manjuprasad, sir, shall we start?
Yes, ma'am, we can start. So already 91 participants are there. So others, they will be joining. We can start the inauguration. One announcement, all the participants. So we have muted all the participants during the inauguration. So I request all to cooperate. Once the session is going on, we'll just enable all this option so that you can raise any queries or any particular thing. So during inauguration, everyone will be in muted. Thank you. Madam, you can continue.
Sir, please unmute Principal, sir.
Oh, just. Yes, ma'am. Principal, sir, can we start, sir?
Yes, we can start.
Okay. Arpita, madam, we can go.
Yeah. Good evening to one and all present here. I am Dr. Arpita Shankar SI, Associate Professor and FDP Coordinator from the Department of CSE A&ML, and I'll be your host for today's program. It gives me an immense pleasure to welcome you all to the AICT ATAL-sponsored Faculty Development Program on Robotic Operating System 2 and Artificial Intelligence for Next Generation Robotics, organized by Department of CSE A&ML, GSSS Institute of Engineering Technology for Women, Mysuru. Before we formally commence the program, let us begin by seeking the blessings of our Founder Secretary, late Professor B.S. Pandit Sir, and late Srimati Vanaja B. Pandit Ma'am, former Honorary Secretary, GSSR, whose vision, dedication, and values continue to inspire and guide us in all our academic endeavors. With these blessings, we now begin today's program with the inaugural session and marking the formal commencement of this faculty development program. At the outset, I extend a cordial welcome to all the dignitaries and participants who are connected with us online today. First and foremost, I warmly welcome the esteemed resource person, Dr. R Prakash, Professor and Head, Department of Mechanical Engineering, NI, Mysuru, and Mr. Raghunandan B., CTO, Synaxia Global Solutions, who have graciously consented to share their expertise and knowledge with us in today's sessions. Along with them, I also extend a warm welcome to our other esteemed resource person, Mr. Shubham Nandi, founder Rigbitel Labs, Mr. Stafford Mikhael, CTO, PRS Neuroscience and Mechatronics Research Institute, Dr. Vijayalakshmi MN, Associate Professor, RV College of Engineering, Mr. Darshan KT, Tech Lead, Robotics, Hive Robots, Denmark, and Mr. Murugam C, Senior Robotics Engineer, Rupayatha Robotics. Though they could not join us during the inaugural session, we look forward to their valuable interactions and sessions in the coming days of this FTP. I also extend a warm welcome to Srimati Anupama V. Pandit Ma'am, Secretary, GSSR Mysuru, and Shri R.K. Bharat Sir, Board Member and CEO, GSSR Mysuru. Though they could not join us for the inaugural session, they have conveyed the best wishes for the successful conduct of this FDP. It is a privilege to welcome our esteemed Principal, Dr. M. Shiv Kumar, GSSS ITW Mysuru. Sir's visionary academic leadership, constant encouragement, and unwavering support have always been a great source of strength to our institution. I would also like to express my sincere gratitude to Sir, as his guidance and motivation have played a significant role in inspiring and encouraging me to continue my work in this domain. We are truly honored by your presence, Sir.
Thank you.
I also extend a warm welcome to Dr. Manjuprasad B., Professor and Head, FDP Co-Coordinator, Department of CSE A&ML. His dedication, leadership, and constant support have played a key role in the successful organization of this FTP. We are truly fortunate to have such a supportive and motivating HOD. We warmly welcome you, sir.
Thank you, ma'am.
I also welcome all the heads of departments, faculty members, research scholars, postgraduate students, industry participants, and all the enthusiastic participants joining us from various institutions. On behalf of the organizing committee, I once again extend a warm and heartfelt welcome to everyone present here today. As we all know, the AICT Training and Learning Academy plays a crucial role in empowering faculty members through high-quality training and emerging and futuristic technologies, thereby strengthening technical education, research, and innovation across the country. In today's rapidly evolving technological landscape, ROS2 has emerged as a robust, scalable, and industry-relevant middleware for modern robotic systems. When integrated with artificial intelligence, robots gain the capability to perceive their environment, learn from data, and make intelligent decisions autonomously. The significance of this FDP lies in bridging the gap between traditional robotics education and contemporary industry requirements, particularly in the areas of autonomous systems, AI-driven navigation, intelligent perception, and real-world robotic deployments. This 6-day FTP, scheduled from 5th January to 10th January 2026, is designed to provide extensive hands-on exposure to ROS2 architecture and communication, robot modeling and simulation, integration of AI with robotics, object detection, and autonomous navigation. To give you a clear overview of the program, I will briefly walk you through the day-wise structure of the FDP. Day 1 begins today with the inaugural session, followed by the technical sessions on Introduction to Robotics and Robot Programming by Dr. R Prakash, Professor and Ed, Department of Mechanical Engineering, NI Mysuru. This session will help the participants to build a strong foundation in robotic concepts and robot programming. The day concludes with the Linux for Robotics and ROS2 Basics, Workspace, Packages and Notes by Mr. Raghunandan B, CTO, Synaxia Global Solutions, providing a hands-on exposure to Linux essentials and ROS2 fundamentals. Day 2 focuses on ROS2 communication mechanisms with the sessions on ROS2 topics and messages and ROS2 services by Mr. Shubham Nandi, co-founder Rigbeatal Labs. Day 3 covers advanced ROS2 topics including ROS2 actions, robot modeling using URDF, and gazebo simulations, again handled by Mr. Shubham Nandi, Rigbeatal Labs. Day 4 is dedicated to simulation and perception with the sessions on mapping and path planning by Mr. Stafford Mikhail, CTO, PRS Neuroscience and Mechatronics Research Institute, followed by object detection in ROS2 and ROS2 projects by Mr. Raghunandan B. Day 5 introduces artificial intelligence in robotics with sessions on Introduction to AI and integration of AI with ROS2 frameworks by Dr. Vijayalakshmi MN, Associate Professor, RV College of Engineering, Bangalore. The Day 6 begins with the sessions on autonomous navigation using NAV2 framework and AI agents, MCP protocol, and AI agent-driven autonomous navigation delivered by Mr. Darshan KT, Tech Lead, Robotics, Hive Robots, Denmark. And these sessions will provide participants with in-depth understanding of autonomous navigation frameworks and AI-driven decision-making in robotics. This is followed by an advanced session on evolving robot intelligence, ROS2 pipelines to VLA-driven control by Mr. Murugam C, Senior Robotics Engineer, Rupayatha Robotics, offering a valuable insights into next-generation robot intelligence and advanced ROS2 pipelines. The FDP will conclude with an online assessment, feedback session, and the valedictory ceremony. With this, now I invite Dr. Manju Prasad B, Head of the Department, and CSE-AML to briefly introduce the department and to share insights into the department initiatives and the vision behind organizing this FTP. Over to you, sir.
Thank you, ma'am. Good evening, all the participants. So, taking permission of all the participants, principals, and HODs. So, I'd just like to brief about CSE-AML department. So, followed by this, we'll have a briefing of about GC+ ITW by our principal, sir. So, our department CSE-AML, this program was launched in 2021. And the program, the CSE-AML program, we have associated with Samsung Innovation Campus. So Samsung has established an innovation campus lab at our campus for all the branches of students, with a sponsor of 3 workstations, 36 desktop, and advanced computing facilities for doing a courses on artificial intelligence, coding and programming, and IoT. And our department of first graduating batch In the 2025, I've obtained 3 rank, first rank, 5th rank, and the 10th rank. So this is the highlights of our department. That is from the first graduates of the CSE AML department. So we have got nearly 45 placements. 45 students have got placed, and with the highest package of 31 lakhs and nearly 23 offers or dream offers. And students are able to get the placement in data analyst role, R&D role, and graduate engineering roles and all. And the department is also having a copyrights and MOOC courses and various events participated by the students. So but coming to the distinguished achievements of our department. So our department has hosted 2 24 hours hackathon at the campus, including internal and external participants. We have a Google Developer Student Club lead on our campus successfully for the 2 years. And 1 students have admitted to master's program for the AI at Boston University, USA. And we have actively involved in the various cloud learning from the Google Cloud Learning platform. So department is provided with high infrastructures with a well-equipped computing facilities available required for the AI and ML courses. So the student club lead. So we have a GSS ITW Google Developer Group on campus. So this is ours is the 4th engineering college in Mysuru, which is having a GDG on campus with a student club lead to carry out various Google initiatives on the AI and ML domain like Vertex AI, Auto ML, and we are organizing many hackathons in collaboration with GDG. So along with GDG GDG on campus, so our department is and the institute is having Google Career Readiness Program, where we have a courses on artificial intelligence and machine learning, generative AI, cloud computing, as well as data analytics role. We'll be giving training the students on various Google Cloud technology in the advanced domain. So these are some of the activities where our students have received swags and completed various courses from the Google Cloud Club. Coming to the development activities of our department. So we have our department have been developed a real-time application for the departmental and institutional need. To name few, like placement portal, institution level admission management system, result analysis, and inventory management system. So we are able to integrate some of the basic AI concept to the real-time application, and it is being used within our department, so that students will get a live idea about like how to develop a project and make it useful rather than only converting into the report or any paper. So they want to make their work useful for one particular community. That is what the focus of our department. And as a result, we have some 5 to 7 applications have been used in daily day activities of the department as well as institute. So these are some of the activities what is being carried by the students of our department. And as part of IPR, so for the applications what is being developed, so we have even obtained a copyright from Government of India. The applications have been registered and copyrighted. So these are some of the activities what is being done by our students. And our students are actively participating in various hackathons, external events, project competition, as well as MOOC course. So these are the statistics, and this dashboard is also one of the outcome of the project what is carried out by the students. So which is being used for our department purpose itself. So these are some of the practical exposures and training what is being given to the students. So these are the articles what is being given by the students for our newsletter and college magazines. So with this, I thank all the participants to just bearing your time for listening about our department. Thank you all. Arpita ma'am.
Thank you, sir,
Yeah.
for sharing about the department. It is now my proud privilege to invite our respected principal, sir, Dr. M. Shivkumar, to address the gathering.
Thank you, madam. I, Dr. M. Shivakumar, working as principal of this institute. I extend a hearty welcome to the resource persons of the ATAL FDP, 5 days ATAL FDP on robotic operating system 2 and AI for next in robotics. See, our institute comes under the umbrella of Gita Shri Shikshana Sangha, situated in Siddhartha Nagar, Mysuru. Gita stands for Bhagavad Gita, and our association starts with the intention of teaching Bhagavad Gita for the school children. Hence, the name Gita Shri Shikshana Sangha came into picture. And it was established in the year 1975 due to the vision and initiative of our honorary founder secretary, late Professor B.S. Pandit sir, who has worked as a physics professor in SJC Mysore. And after his demise in 2008, Anujabi Pandit madam took charge as honorary secretary, and she worked as honorary secretary till 2024. And whatever is the vision of our honorary founder secretary to give the quality education to the students, and in particular quality technical education to the women for their empowerment, and what was done by the both our honorary secretaries, Professor B.S. Pandit sir and Manjabi Pandit madam, and Srikanta S. Pandit and Rukmani Pai S. Pandit were his parents. Our past presidents are late Shri B.K. Kenchegowda as first president, and late M. Anandrao as second president. And the present management of G3S consists of Dr. M. Jagannath as president, Shri B.V. Srinivas Gupta as vice president, and after the demise of Anjapi Pandit madam, Srimati Anupama Pandit, she took charge as secretary, and Shri O. Pratap Kumar is working as joint secretary, Ratnama Kenchegowda as founder member, and Shri R.K. Barasar as board member and CEO, Shri B.K. Nataraj as board member. And see, the institutions run by G3S are, in addition to the G3S Institute of Engineering Technology for Women, we have Architecture College for Women, we have a school, Geeta Bharati School, and Bantwai Madhava Shanai High School, Badri Prasad Pre-University College, and we have a degree college by the name G3S Sima Subha Mahalakshmi First Aid College, which is in the opposite campus. See, the other schools, the school PU, they are situated in the Siddhartha Nagar campus. See, our institute started in the year 2003 with the objective of giving women empowerment, and our institute has 2 years of recognition, and is housed in 11.22 acres. Next. And see, our out of the 6 branches, 6 UG branches, 4 UG branches are accredited by NBA, ECCS, IS, and EEE. And out of them, 3 branches, that is EC, CS, and EEE, they are permanently affiliated to VTU, and we have got a very good amount of grants from various funding agencies. Recent one is 3.75 crores of grants from the DST New Delhi under Inclusive Technology Business Incubator Scheme, that is Nidhi ITBI, and management of G3SR has given 75 lakhs totally. 4.5 crores have been invested on the establishment of incubation center, and we have established Section 8 company by the name G3S TBIF, and it is working as a separate entity. We have CEO, incubation manager, incubation associate, then tech associate, accountant. We have separate staff member, and therefore the G3S TBIF is working as a separate entity. For that, our president, Dr. M. Jagannath and our secretary, Madam Anupama Pandit, they are working as directors. And our institute is having MOU with University of Sanyo, Italy, and Multimedia University of Malaysia. And as Dr. Manju Prasad told, we have Samsung Innovation Campus in association with Samsung R&D. And the departments have conducted several hackathons in association with the companies. Recently, AML has conducted 24-hour hackathon, and even this is second hackathon from CSE AML. Similarly, EC has conducted 28 hours hackathon, and we have a couple of industry-supported scholarships. FINIA is giving 15.2 lakhs of scholarship for 28 students, and Strider Electric is giving the scholarship for 8 students, 50,000 each. And we are having HP Center of Excellence in our campus, and we have organized, as I told, hackathons in association with the leading MNCs. We have conducted the final of the hackathon in association with Cognizant, and we have conducted hackathon in association with HP, and we have established a NI LabVIEW Academy School in association with National Instruments, and we have Google Developer Group on campus. And this is our institute core values. And we have we are offering 6 UG branches, that is EC, CS, IS, EEE, CS, AML, and ADS. And out of them, 4 are accredited by NBA New Delhi. And our institute is accredited by NAAC for the 2nd cycle. And we are also offer 2 MTech programs, one in CSE and another in EC, that is Digital Communication Networking. Also offers MBA program with specialization in marketing, finance and HR, and business analytics. We also offer dual specialization. These are we have the research centers in almost all the departments, and these are the details of the research guides available, and the number of research scholars doing research in various research centers, and the number of research supervisors available, and all these research centers are affiliated to the VTU Belagavi. And we have 200 kilowatt rooftop solar in our campus as a green campus initiative, and we have 27 solar sheet lamps. And we have STP plant. This is the inaugural function of the incubation center that is sanctioned. And this is the inaugural function at IIT Delhi campus, and Dr. Padmashri was a principal investigator, attended the inaugural function. And we have HP Center of Excellence in association with HP, and HP has donated 2 server racks, and all the software that have developed, they have been installed in this particular server, and the details have been already given by the Dr. Manju Prasad. And we have the domain-specific students clubs in all the departments. We have IoT club under CSE, FAST club under ISE, then Google Cloud Club from AML, and Port Club from ADS, then Renewable Energy Club EEE, and from EC department we have VLSI Club, Wireless Communication Club, Edit and Robotics Club, Signal and Image Processing Club. And we have our institute is associated with various professional societies like IEEE, IST, CSI, IET, ISY. Then also we have active NSS unit and the Youth Red Cross unit. And these are some of the activities. And our students have secured ranks in the university examination, and these are the details. And our students have secured 37 university rank right from the inception. And these are our institute has got a very good industry association, and these are the details of the industry visits by the faculties and students, and the visit by various industry leaders to our institute. And we have certification programs from various industries. We have certification program from Amazon Web Service, Fortinet, Salesforce, MuleSoft, VAPath. And also we have the program under the Samsung Innovation Campus program, and they are offering 250 hours each of program in the area of coding and practice, AI and IoT. And these are the facilities created under the robotic lab and the AR VR facility, and we have a state-of-art robotic lab, and that is using the 30 lakhs of grants that is from me, and another 40 lakhs which is currently in progress. For that we have established facility in the area of advanced robotics, AR and VR, and these are the facilities created. Also we have got 43 lakhs of grants from the DST Curie, and these are the facility created, and Dr. Jayant is working as a nodal officer. And these are and we have got Modrob
Thank you, sir. Thank you, sir, for briefing about our institution legacy to our participants. Being a woman, always I feel proud to be the part of our institution. Before we proceed further, I kindly request all the dignitaries, resource persons, and participants to please turn on your video cameras for a group photograph. I request everyone's cooperation for a few moments while we capture this memory.
Turn ಆಗ್ತಾ ಇಲ್ಲ ನೋಡಿ.
Sir, just a minute.
Enable ಆಗಿಲ್ಲ ಅನ್ಸುತ್ತೆ ನೋಡಿ.
Yes, sir. So now I request all the participants to just turn on your cameras.
Kindly turn on the video.
Just a second. Okay, thank you all.
Thank you all. We sincerely thank our management for conveying their best wishes for the successful conduct of this program. I sincerely thank the AICT ATAL Academy for granting us this FTP and for the support, which has enabled many participants to benefit from the quality training in emerging technologies. We also extend our heartfelt gratitude to our principal, sir, head of the department, esteemed resource persons, faculty members, and organizing committee, and all the dignitaries for sparing their valuable time and graciously participating in the inaugural session. We now move on to the today's technical session. I would like to invite Ms. Sumana, Assistant Professor, Department of CSE AML, to introduce the resource person to the participants.
Thank you, ma'am. Today, we are pleased to introduce Dr. R Prakash, Professor and Head with over 30 years of rich experience spanning industry, academia, and university administration. He is currently serving as Professor and Head, Department of Mechanical Engineering, NIE Mysuru, and has earlier held key leadership roles such as Dean, Industry Relations, PG Coordinator, and Head, Center for Automation and Robotics. Dr. Prakash has made significant contributions in the area of automation and control, robotics, IoT, sensor materials, and advanced manufacturing. He has guided 5 PhD scholars to completion and with several more currently under his supervision, and has guided 58 MTech students. He has an impressive research records with over 70 publications in reputed SCI and Scopus indexed journals, along with patents in the area of real-time remote laboratory system for engineering education. His work has also attracted research funding of approximately 1.8 crore. Dr. Prakash is a recognized resource person for VTU, L&T, and several premier institutions, having conducted numerous faculty development programs, corporate trainings, and workshops in mechatronics, hydraulics, pneumatics, PLCs, robotics, and automation. In recognition of his outstanding contributions, he has received the Distinguished Professor Award in Automation and Robotics and has been honored by VTU for his dedicated service. We are honored to have Dr. R Prakash with us today and warmly welcome him for his session. Sir will be handling the session on Introduction to Robotics and Robot Programming, which will lay a strong foundation for the advanced ROS2 and AI sessions to follow. I request Dr. R Prakash sir to kindly take over the session.
Thank you, ma'am. Thank you for the introduction. I would thank the management of GSSS for giving me an opportunity, and AICT ATAL team for providing funds for the region to facilitate a good learning in the area of robotics and AI domains. Thank you, one and all, the participants also, and other resource persons who joins along with me for the further sessions. Thank you. Shall we start?
Yes, sir. You are able to share?
I'll just check.
Sir, I have made you as a co-host, so I think you will be able to share and present all the things once you just confirm, sir.
Can members can see this slide?
Yes, sir, it's visible.
Yeah. Okay.
Yes, sir.
Shall we start?
Yes, sir.
Yeah. Good evening to one and all. Let me tell a brief introduction before we start. Just after completion of graduation, I have started in the industries and worked around 10 to 12 years in the industry, and later moved to academia and become a special officer for the VTU and served around 6 years in the area of automation, and got some hands-on from Germany during that time. It's a long back. I have left many of the depth working towards research and coding and other things. However, I would take up through the basics which is necessary for you to take forward the further good learning from the people. Of course, I have my students in the resource person list. Raghunandan is connected with me, and Darshan is connected with me. Many other students have been undergone training and learning through our centers. So with this, from the National Institute of Engineering, I thank once again every participants and the management of GSSS and Principal of Shivkumar sir from the GSSS, because we have worked together for the 3 doctoral programs which they have done from their institute. Arpita is also one among the PhD doctorates who have done on the particular field. So to start with, I will be covering on a few aspects before we take into this. Introduction to robotics, growth of robotics in India. I'll be just talking what is going on in and around now, and components which is necessary to build a robot, which includes the sensors and actuators little bit in detail, and softwares used in the area of robotics and simulations of the robotics especially, and robotic work, what we have done at the center, and a bit on the ROS introduction part of it, and few other projects I'll be covering. To start with, robotics is an application of engineering. As you all know, it's an interdisciplinary branch of engineering and science. We work with different branches like mechanical engineering, electrical engineering, electronics engineering, and computer science engineering. So for any institution to grow, I think these kinds of branches would really help to build the skill level among the student and the faculty, and definitely helps in the larger aspects of the growth of the institution as a skill-oriented institute. And robot is a mechanical device with the links and joints, and actuated by motors, or by sometimes even a hydraulic and pneumatic actuators can be involved in it, and guided by sensors, controlled by different kinds of controllers or circuits, embedded boards, etc., with an intelligent input given through a software framework. To tell, based on the mobility, we can classify them into 2 basic categories. The first
Sir,
one,
sorry to interrupt, sir. Can you please put it in a slideshow, like participants are requesting?
yeah, it's okay.
Yeah, now it's good.
Yeah.
Thank you, sir.
Yeah. We can broadly classify into 2 categories. One is called as a non-movable robots, which we find it in the industry as articulated robots or gantry kinds of robots. Today, the many industries are integrated with these kinds of robots in the line automation aspects, or in the discrete manufacturing also extensively being used in various applications like welding, painting, many applications. Of course, this is one of the major area where India is progressing, because manufacturing is progressing in India, and industries are ready to invest money to increase the automation level because of accuracy, and to avoid the repetitive work in the industry. The industries are going for a integration of robots within the company. Broadly, if you take, many players are there, even in India. The major ones may be KUKA, ABB, Universal Robot, Escava. These peoples are working, and the integrators. These are the robot manufacturers. However, the integrators are buying these robots and fitting in different lines, and many organizations in Bangalore and other areas are dominantly increasing in the recent days, and they are one of the sources for our students and even for faculties, they're even ready to give a training to the students for a month or 2 months for a younger faculties. So this is one area where the industry is growing, robots are growing, and the learning towards robots are growing. And the second area is we have a drone. As you all know, in the recent conditions where Indo-Pak things were happening, and we were seeing a lot of drones are coming into the Indian land, and our people used to, means rapidly in the defense segments and in other critical areas, the drones are being extensively used, not only in the defense. Recently, it is being tried at different forms for monitoring and even spraying chemicals and watering the plants. All these kinds of activities and research is going on. And of course, even many of the aero related even small segments have grown, and they launched that in the defense segments, and they try to using some launch pads which are unconventional and helps the defense segments. So recently the Mysore industry has supported the war of India in many things. This is the one good news for all of you to tell. The unmanned kinds of vehicles which are being designed and deployed to combat the military applications. So the third one is movable robots, where we find a legged robots or a kind of a snake kind of robot or a kind of a wheeled robots are being deployed. And this was a big segment in countries like US and Japan and other countries. However, now in the recent days, many of the startups are picking up, and they're able to produce these in India and give it back to the other countries. So when we say a robot, it is not only a particular thing, it's an automated device. I'll also link some of my inventions to the use of this kinds of developments in and around Mysuru, because Mysuru is now considered as one of the city which is clean and good, and beyond Bangalore aspects, it's one of the critically considered city. So in this area, we have a legged robots, wheeled robots, and unmanned aerial bots, as I said. These becomes the total robotics thing. Need not be. Even we invented a cooking, and we have patented a cooking device. That also we call it as a robotic device. Automatically, without intervention, it can cook and keep the dishes ready for you. All these inventions comes under the category of robotics only, because we are avoiding the human intervention in any automotive aspects, automation aspects, all these areas where we use these kinds of knowledge. Then we can call such devices as a robotic devices. So coming back to the integration of the branches. So as you know, mechanical is one of the core branch which is supporting in building the structures, link joints, and other things. The areas MEC covers is design and 3D modeling of robots. We have developed a few robots, and even we patented that, and IP was sold to US. So like this, many of the design aspects of the robots, and look how it looks aesthetically, improvising the aesthetic aspects of it, and suitable material and strengthening it from the different kinds of supports that we are able to give for a particular design. And manufacturing, we need a relatively hand layup or a RTM kind of resin transfer kind of things to produce the parts, or even 3D printing machines sometimes. All these are necessary, which are corely linked with mechanical engineering aspect, but that can support the robotics in total, and that can help the others to integrate and work with it. And electrical point of view, selection of suitable motors. As you all know, the motor is a big area where we have AC, DC, and different kinds of motors like induction and DC, stepper, servo, lot of various kinds of motors are available in the market. And depending upon the ruggedness and the requirements, the selection of the motor has to be done very accurately to have a very good system. And electrical department would rather support such kinds of thing, knowledge and the selection of the motor and amount of torque required, speed and operation requirements, either continuous or stepping kind of a thing. And next is sensors and feedback systems. When we say a robot, if you compare a robot with a human now, human is given with a different kinds of sensors, God gifted, like ear is there, nose is there, skin itself a sensor. So we also try to integrate some of the sensor to make the system smarter. So integration of the sensor, when it comes, it can be a sensor with a signal conditioning part of it, either amplifying it, converting it into AC, DT, or filtering some of the things. All these aspects, it's in a bigger aspects. If you take the complete selection of the sensor, signal conditioning aspects of the thing, all will come in the area of electrical and electronics. And in the electronics, more widely we concentrate on the board development, circuit boards, or a few controllers which are able to handle all the IOs and required analog and digital and other aspects of the system, and making all the connections between the circuits. As you all know, in the college level, the student may use a breadboards and pin wires to pin it and try some of the basic project work. But when you take up with the board level, we may have to generate our board, fabricate it to a level where it is reliable and adaptable to a machine, to input into a machine and works for a longer time. All these aspects will come into the in the area of electronics. And of course, software is like flavoring. So by coding all these necessary things, we can give a lot of input to the system level, and we can make the system work smarter. That is the work of the software. They try to code or write some intelligent algorithms. Of course, nowadays need not be required to write. Few inventions and other things only we try to patent, write a code and patent for a specific application. Otherwise, many of the code made available, and we can pick that codes and use it in our application areas. And when we take all these engineering aspects and moving on to the robot, requirements for a robots to become to work as an intelligent thing or in an intelligent environment, we may have to look at a word called autonomy, means giving freedom to it and make it to work as per the requirements, achieve the goals and targets as per the given target level. Autonomy is given to execute. So robot have to be capable of achieving such tasks given without a human input. It should not ask for hand control devices sometimes or other kinds of devices. It should be able to completely take on and complete such targeted goals on its own. That is referred to as autonomy. And robots have to be able to make and execute their own decisions. Here, this decision refers to as it moves, may not be in the static, quasi-static, and dynamic situation. A lot of things is going to change, and it should be adaptable to the changes and make its own decision. Suppose if somebody has come in the middle, or the door is closed when it goes to the nearby, so it has to make some decision and take the next step as per the requirement. So decision making things also needs to be incorporated into the autonomy. And the second point is intuitive human robot interface. It should be able to the use of robots in a smart homes or kinds of thing. in that time it should work with a human being. It should listen to a grandfather or mother who is not able to walk. She's talking to a robot and able to tell something. It should be able to understand that and try to work with a comfort level where feels safe. Commands to robots should be natural for inhabitants, and adoption is robots have to be able to adjust to the changes in the environment. These are the three areas we look at it while designing any of the aspects. As I told you, industry, if we say an industry now, how the robotics is dominating the industries of the today's industry aspects of it. I have taken a case of a car. Now the car manufacturing production rate has rise from the previous level. You cannot even imagine. Per hour, they are able to deliver hundreds and thousands of cars. Some of the shops is able to do such a big scale. Otherwise, when we say a car, we were thinking to build a car, we need a month together. So need not be today. Many of the robots synchronizedly are in a cobot environment, work in an industry, and helps in welding, assembling, and all these aspects of it. And the many aspects of the robot today is welding, assembly, cutting, drawing, drilling, gluing, inspection, machine tending, machining, milling, palletizing, pick and place kinds of robots. You can see many of such robots. And even 3D printing machines which are emerging is also a kind of robot which has arrived from a gantry robot environment and made available as a printing machine today for the today's world. And of course, the major widely accepted is welding, because it is hazardous to human, and human can be lose their eyesight if they are continuously working. And the other area may be painting, where toxic environment is there and not able to work with the systems. Of course, the integration of the robots need not be only for such areas. Today, even the industry is using to increase the productivity and avoid the redundant work. The below picture, which is showing a company in the Bangalore, which is building the automation lines to the various bigger companies which are coming in the India. And they build the complete line, automated line, which uses a gantry robots with a kind of a beam and able to work in XYZ coordinates to pick and move the objects, heavy objects especially. If you observe, even the UP defense sectors which has grown in the recent days, they have taken the assembly lines from Bangalore. So this is news for you. And they're able to assemble even the rockets and other things, heavier articles. And the line was built by a Bangalorean company. So this is the one area. And the second one is today, India is picking up. I cannot say completely picked up. Industry segment has grown, but industry segment with respect to wheeled or movable, it's picking up now. Few people who are working on is Mini Group with the association of Infosys software stack. They are working in a big way to put in their material handling equipment inside the industries for the autonomous moving of the heavy materials in the shop floor areas. And largely, one more innovation has been taken by my student when he was in India, Darshan KT, on a forklift. So forklift means it's as you are aware, it moves within the industries with a driver, and the driver is able to lift the heavy material and move to the next targeted point. And that has made autonomous when he was here itself. And now many of the industries, 2 industries are working on that, and they are developing the forklifts for the industry segment, which is autonomously moving within the industry. And if you observe the airports, the bots are serving the people in the airports nowadays, and luggage moving robots have come in the airports. One of my students from Nagpur has pitched his robot to a Mumbai airport. And I think recently you can see Mumbai airport is being given assistance of robots. So of course, in the hotel, we need to work more. Hotel environments are totally different now, and few of the Western countries are even working. And we are working with one company called Robotica, a Mumbai-based company who is extensively working on a restaurant and other service kinds of an application, wherein recently we have registered a patent which can navigate from a ground floor reception to a multi-floor rooms, where the robot is autonomously is able to take the lift and move to the respective floor and go to the respective room and work. Of course, in Indian restaurants, you're now beginning it is. You're not seeing more in numbers. Definitely in the next coming 5 years, India will pitch in this area. And we have registered a patent of delivering a common bot which can take 2 to 3 things in the hospitals. That is, one is waste recovery, food supply, and other water bottle supplies and other kinds of things, food and water supplies. And these are the supplies that needs to be done. To cater these services, common bot has been designed in Mysuru in association with Robotica, and this has been patented. And of course, hospital environment is the other one, and home, houseworks, cleaning, Roomba is there, and other vacuum cleaning kinds of elements are working, and it's picking up its numbers also in India. Okay, so these are the areas. Of course, it's a very interesting area. People are trying with wheeled, not yet more legged ones in India. With wheeled, people have done some demonstration yet for an educational institution as teaching thing, and hospital bot navigating to carry the food, all these things. Of course, we are also working on this in Mysuru in association with a few companies. And one interesting thing is Arpita itself has worked on few such work for her PhD work. And one of the interesting things is when the glass is there, the navigation parts were researched and few articles are being published, and multi-floor navigation, few articles has been published, and few article with common bot serving multi-purpose services for these kinds that can enhance the market. So in that direction, people are now looking to raise the value. So I have shown some of the pictures of the movable robotics, so which is in the material handling, cleaning, food supply, and many of the agri-related aspects. And fortunately, we have received a funding from GSSS incubation itself for developing a agricultural bot which can pick fruits and flowers kinds of thing, and we are working on that. And one of our student from NIE is taken a lead in it, and we are working on such things. Of course, before we move on to any robotics, sensorics becomes a very important. Sensors in a robot is a very important aspect of it. We will go one by one. As a participant, how do you understand these sensors or sensors knowledge, sensorics knowledge, and bring it into an application in a robotic environment? So let me take one by one and take with inductive sensors. Inductive sensors as a sensors which can detect the conductive materials. So when I say conductive material, it can be an aluminum, iron, copper, all this. Any conductive material, if you try to bring nearer to this sensor, it will be detect such kinds of things. So that means when you go and buy this, the letter I will be written on the sensors in the sensor specific sheet, which is pasted on the sensors. That refers to an inductive sensor, which works on the principle of induction, a primary and secondary kind of thing. Here, primary is the sensor core and coil, and secondary is your object itself. So in this principle, when you bring very close, this is a proximity sensor. When you bring in the conductive material nearby in the sense, we can call it as a 50, 60 centimeters or mm, sorry, okay, 60 mm, okay, or 70 mm max. So a very short range. And these can detect such things. So when you say, where do we use this in a robot? So many of the gantry lines and many of the articulated robots, which I have shown in the earlier slide, if it is picking a material of a metal object, so then we try to fix this at the end effector, near the end effector, in a proximity distance, so that when the robot moves nearer to the part, it is able to understand I am nearer to the object and the motion is going to change and go slowly and pick the part, heavy part, and go for the assembly. So these kinds of things will be done with the inductive kind of sensors. Now, moving on to capacitive sensor. So as you all know, capacitance is a function of epsilon naught, epsilon r, and area and the distance. These comes into picture. Here, primary and secondary electrodes can and the charge. With this, we are able to find even conductive, non-conductive, liquid, fluids. All these materials can be detected using the capacitive sensors. Of course, even today, many of these capacitive sensors are used to detect the waves in a sea, how the patterns of the waves are going to change. All these aspects can be detected using the capacitive sensors, which I'll repeat, it is again a proximity sensor with a closer distance, okay, and can be utilized in detecting the conductive, non-conductive, liquid, fluids, and other materials. Of course, I have used this sensor in finding the cocoons. If you see, cocoons means it's a silkworm which create, and we were use this to develop a automatic cocoon cutting machine. So where we cut the cocoon without damaging the worm, so that the worm can be captured and made use for its reproductive and other purposes, biological purposes. And cutting that is a very sensitive, very accurate part. It has to be oriented, brought very close, and then cut. And once you cut, the worm should be inside. You have to also image process it and know that the worm is in, and you are able to cut now and cut it, and that to go in a rapid phase. The quantity of cutting should be high speed cutting we have to do. So which is an invention again. Our sericulture department has been associated to do this work, and we have executed this project wherein we used it. Not necessarily, we can make use of such sensors in many other aspects. And the third sensor which may come into use in any of the robots or devices like what we discuss as a robot is a magnetic sensor. Magnetic sensors can only detect a magnetic material. I'll link this to a particular application of a autonomous forklift development part. So when the driverless vehicle is coming and the lifting arm is going to be down to the ground level and lift the object and move up to a higher level. So wherein while traversing below, we don't use any other sensors than the magnetic sensors. We put a magnetic sensor at a certain height, checking the ground height, which will be aligned in such a way that the forklift arm will not hit the ground. If it hits the ground, your tiles may go, your other things can damage because it's a heavy, is also heavy in nature, and when it is loaded, definitely it is more dangerous. So I repeat, magnetic sensors can detect magnetic materials when a magnet is come closer, but the range is a bit higher compared to these two, but still it is considered as a proximity sensor. Now, move on to the photoelectric sensors, where you can find many kinds of sensors in the market, which is giving you a lot of kinds of sensors which can be integrated to different purposes. Even your LiDAR and other devices can come under this photo kind of a principle. So in this sensors, we have different types. I'll cover that also in my next slide, because there are different types will come here. And we have one more sensor, which is ultrasonic sensor. We try to create a high frequency wave, and that is allowed to travel, and the travel it traverses and comes back, and we try to pick that and get the either distance, flaws, obstacles, all these kinds of things can be taken as a feedback, and it will be used. And the type of the sensor, we call it as a ultrasonic sensor. And of course, the other one is micro and radio wave sensors, which is kinds of a signal which we try to use it in the robots and capture that and try to use that signals and navigate within the required area. Of course, one of the thing is here we can see few of the aspects like beacons, and one company in Bangalore which has done its navigation bot for an indoor industries using beacons as a devices. It fixes up a minimum number of beacons, and your bot is able to travel and do whatever the autonomous work that you are going to dictate. I'll list out few of the in and around Mysore and Bangalore industries. Mysore is less comparatively. Now we are trying to bring in industries in Mysore, but Bangalore is already more matured. We have an industry for beacon-based navigation. We have a forklift R&D center. We have a Great Wall Motors autonomous R&D, Daimler Truck R&D, Benz R&D. You name any of the bigger players who works on autonomy and who works on the Mini Group for material handling. All these people are there in the Bangalore. This is the one of the hub of softwares, what we can call. When we say software, Bangalore is not only supporting the completely finance softwares kinds of thing or other. It is also supporting manufacturing or many R&Ds. Many outsiders have put their R&D centers in the Bangalore and is able to support such things. And now I'll one by one I'll take a little into the each one. What is there in an inductive sensor, and what is there in a capacitive sensor, what is there in a magnetic sensor, like this. My top left figure shows an inductive sensor, which is an industry grade inductive sensor built to some standard protection claw, IP protection we call. And if you see the front of it, you can see a ferrite core and a coil arrangement. So when we say an induction, normally we go back to our studies and we say primary coil and a secondary coil. When you pass a current through a primary coil, it is going to induce a fluxes in the secondary coil. So with the same kind of a thing, so we are bringing the object nearby that acts as your secondary, and we have a primary which is built and powered by through the sensor. It's a small thing. When you bring in, so we can find something is sensed and some changes is being undertaken at the current level or in the thing, if you're able to pick up that signal changes and amplify it and build it, you can record it. And not only detection, the presence of the metal object, even you can go up to a level, you can segregate the material. When I say segregation, you can segregate Fe360 steel with other steels. The steel itself has a band of steels. So, or you can differentiate a steel between a copper, aluminum, brass, and other materials. So, we have developed a bots which can only pick up coins of 5 rupee, 1 rupee, 2 rupee, and put it into separate baskets. These are all possible with these kinds of sensors. You throw a coins on the floor, and my bot can only pick the 1 rupee coin and bring in and sort it to a certain areas. All these are possible if you're able to understand the working principle of this. So how this ferrous and non-ferrous can be found is, when a ferrous is there, you have a eddy current losses also comes into picture, which is higher than the regular losses. So we can differentiate using those principles. This itself a 1 hour session. I don't want to go into the deep of it. So next one is, I've shown a sketch wherein a capacitive sensor, target, and an electrode, sensor, electrode, and a target. As you know, C is a function of epsilon naught, epsilon r, area, and inversely proportional to the distance. So your value of capacitance is going to change, and that can be made in the sensing aspects of it. And the third one is magnetic sensor. If you observe the below figure, if you bring in very close a magnet, so the magnet will have a flux traveling from pole to pole. And as you bring in even you change the direction of the pole, you can create a spaces where we call it as a point, and single point, 2 point, and 3 point switching kinds of thing, which enables you to mount your machinery even offset and detect. My hand is now offset to my laptop, but still I am able to detect my hand has reached there. So these kinds of aspects can be done using a magnetic sensor. One of the other advantage of magnetic is you can put it inside the material. On the surface level, it cannot be seen, but still you can get the magnetic properties and detection properties using this kinds of a sensor. So that is why upon developing this, the first device which has drastically changed the industry is your actuators, which are controlled by pneumatic actuators, which are controlled by magnetic sensors, which are mounted on above the surface, but the cylinder is inside. But even the cylinder material, when it is reached, there is a ring, magnetic ring provided on that piston. So when the magnetic ring come closer to the sensor, which is above on the surface level, is able to detect it and give a return signal for the actuator to go back or come slow. All the kinds of motion development is possible by using these kinds of buried magnets inside and put the sensors outside the surface levels. And I have told you in the sensors which uses opto sensors, we have many type. The first one is a direct sensing type, wherein you can find a transmitter and receiver on the sensor itself, and a transmitter will transmit a light and it will reflect back. A receiver will receive it and uses that to detect the material. However, the opto sensors are a bit of a long range sensor. Today we have even covered up to 10 to 15 meters of distance. So even more can be done as per the research. But again, there are some research is going on to use some of the other aspects of it to focus the light. So now in the next slide, and I'm giving it 3 different types of optical sensor. Here, if you look at this figure, so here The direct detection sensors are like this. Object is there. Your transmitter and receiver is there, which is nothing but your sensor now, direct detection sensor. It sends a light and takes back. And the next picture just below that, you are finding a through beam sensor. The principle in the through beam is a transmitter on one side and the receiver on the other side. We have to align these two devices. So like in a lift, when you put your hand, it is able to detect. So like that, your transmitter is there, your receiver. A ray of light will be transmitting from a receiver to a transmitter to a receiver. And if you're able to avoid that by inserting something, suppose you find a vehicle is moving through the gate, we're able to detect vehicle is moving, people movement. All these detections are possible. This uses airport applications of this very vast, and a lot of sensors even put across the runways to know each of the velocities calculation and the flight aspects of it, and they try to correlate that with the other aspects of the requirement and compare the flight is okay or not okay. And the third one is retroreflection type of sensors. When we say a retroreflector, these are some kinds of materials upon which when a light falls, okay, you can get the deflection back, and you can get some of it. If anything is passing nearby or this, we can identify that. So that is the aspects of the third category of the optosensor. And in the right side, I have shown you an ultrasonic sensor. If you see this sensor, a transducer is there, and a decoupling layer is there here, and foams, integral foam and piezoceramic material is inside here. And we are going to take this as a thing, ultrasonic transducer, which produces a wave, travels and hits the object and moves back. Okay. So again, you have a signal processing aspect, and we use a lot of signal conditioning devices, operational amplifiers and other things to get the right output. Among with other than this also, many of the time in drones and other applications, we need to know the pressures. We use the pressure sensors. In the pressure, we also use differential pressure sensors and absolute and gauge pressure sensors and IMU sensors, gyro sensors, which can even give the motion, XYZ motions of it. All these can be used. We have used one of the sensors, gyro and IMU, in when we developed a hand glove for the deaf and dumb student to take the signals of the hand movement, sign conventions, which deaf and dumb people used to do, and give that as a text on a mobile phone level. So these are the many of the sensors which are being extensively being used. Of course, many other sensors in wearable equipments today has pitched in, and many good amount of sensors is supporting. Temperature and humidity sensor, DTH11 and other kinds of sensors, and H2 Bluetooth beacon for indoor navigation, and even you can think of BLE sensors with RDK kinds of this RDK sensors we call, and moisture sensors in many areas you can find. All these becomes a sensor part. Of course, now I hope you have broadly understood there are many kinds of sensor. You have to know the working principles of the sensor to be used in a robot for a particular application at a particular place to get an effective and efficient working of the system. So now among that, LiDARs will be covered in the next thing. Cameras will be covered. I have not taken that because in the ROS, as I know, you need to know how to integrate the LiDAR sensors, how to use the depth cameras, 2D or 3D depth cameras in the next session level. So I have omitted that, and I have just covered the other sensors. Of course, when you take a controllers, there are many controllers which are generally available as a general boards. So few of the general boards I am covering. So one of the easy accessible board is your Uno family, Arduino family. In that, Arduino Nano, Uno, Mega, all these boards can be extensively used to integrate some of the things in your robot. And I had given the picture wherein your pin configurations and digital and analog and other pins with respect to particular models of the Arduino. Okay, if you observe now, Arduino Uno has both digital and analog and PWM pins. Like that, depending upon the requirement, you may have to select the appropriate board and take on the selection of the board as a requirement. Of course, if you move little higher, you can find a mega board which has more number of possibilities you can get out of it. So I have just given you a picture of that. You can get a communication related interrupts, timers also you can get here. Okay, so a lot of other additional things you can get. ADCs are there that you can get. And the next board is Pi. Many of the students or even a small companies may use a Pi, and upon which they put a ROS and other softwares to work on the robotic side. So one drawback may be completely autonomous and multi-application oriented will have a huge data, and processing the data will have a difficulty, and sometimes your processor in the Pi may not be able to provide that, or it may heat up. So if you try to put your hand, it will burn also sometimes. So it is dangerous. Your board can burn, and few of the cooled things are also being introduced in the later stages to make use of the Pi for such applications. So air cooled kinds of things they have developed, a chilled air kind of a thing they have did it. So all this is a possibility. You can use this and run a robot in your areas and try. This is one aspects of it. If you go little higher, we can get a Jetson Intel boards which are much more rugged and capable of processing a larger data. And even people have used Jetson Nano, Jetson board, and upon which they have installed Ubuntu and other software, and they have worked on it. So that means you can use these kinds of boards also for your purpose. In the coming slides, I have highlighted the boards which are Arduino family has, and its voltage and clock speed. While selecting, you have to look at all the parameters here, and you have to know that aspects of it, what all you can get out of this. For example, analog inputs, digital IOs that you can get out of such boards. All these things you have to question yourself and then choose the appropriate board to work on. Otherwise, you may end up with using multiple controllers, and at the end the wiring will be a problem and routing will be a problem. You cannot develop a bus kind of thing. All the things go through a single channel, and avoid the maintenance. Your maintenance will rise, and your reliability of the robots will become a question. When you try to develop all these things, structural aspects of it, appropriate materials, appropriate structuring, and appropriate controllers, and laying of the things that we call it as a channelizing or bus kind of a configurations that we try to take. All these matters when you try to design a product level which can work for a longer duration of aspects. And Arduino Atmega I have listed. I'll send you these information in a kind of a Word or PPT. At the end of the 5th day or 6th day, you can get these information from the organizer. And of course, knowing all this is not sufficient. Knowing the mechanical links, joints, formulas for it, and kinds of kinematics part of it. All this, I would have covered kinematics itself in a one session, but as you are moving more onto mobile aspects of it, I have not taken that. Otherwise, you may have to learn about forward kinematics and other aspects of it, and that is more useful for you to go with the robotics aspects of it. And then when you move on to simulation, before we go to this, robotic things are more complex in nature. A lot of data is there. A lot of things has to be understood. It is always better to go with a simulation first and then deploy it. So when we say this, there are many softwares which are available for just trying it out. For example, for an industry segment, if you take Delmia is there. So Delmia is a software which can supports you to build any factory floor itself, and wherein you can pull on machines, you can pull on robots, and you can place it according to your configuration. That is, we say cell configuration of it, and try out how optimized the state of the factory is before you generate a factory. Because when you are deploying a factory, the investor may be investing thousands of crores or hundreds of crores, depending upon the capacity. Today, the industry is giving an opportunity, and this becomes a big industry now in India. Many of the players are putting their thing and servicing the foreign countries' manufacturing domains also. They completely develop a factory floors and they give it as a service to the outsider. So this is being done in Bangalore. Many of the players are there. Students can get this domain, but only they have to learn some of the simulation software to get entry into industrial domain and some of the towards the mobile robotics platform. So there are many simulation softwares which are available. Delmia is one. Siemens is there. We call it as process simulation by Siemens. We have many players have pitched in such softwares. Virtual testing of robot behavior is also one of the major requirement. So that is a main intention here. Before the real world deployment, we need to do a lot of iterations, a lot of know-hows has to be done. Simulation will help you to reduce your time and give more input, know-how about the system level inputs and the process level inputs. Always, simulation is a big domain wherein a huge market, huge jobs, opportunities are there, and which also saves time and cost. And one interesting thing here is it requires a skilled labor. So I think in the future jobs will be more of these kinds. So you're developing your students to meet the requirements of the tomorrow. Even these softwares may add on features related to AI. I have come across with a 3D software which enables you to deploy your construction or machine erection in the other country, but you are able to see what is happening there and actual distances, exactly what they are getting there. All those kinds of corrections means plant can synchronize with software, and people can be in India or anywhere, who are able to know the in and out of the practical situation which is happening at the industry site level. One of the projects L&T has taken, and many of the engineers were there in India, and the construction site was outside India. So they were guiding the deployment sitting in India. So like that, many such things can happen if you know these domains. Even in our future robots, ABB, for example, ABB robots are controlled by an ABB company itself, so that if any problem arises, people can anywhere, and they're able to know what is the problem, and they're able to solve some of the problems. So these areas are growing. Nurturing the students in this area is a very much important. And why simulation is important is we can have a safe testing and completion of the task before we deploy. Cost effective, faster deployment is possible, and even we can use the simulation to train and teach people what to do and what not to do. That is why the simulation has become a core part in the last war, what we have done also. Many of such iterations and the targets were simulated and done. Most of them were perfect. So simulation enables you to do optimize your targets and do the best of the best work. So again, we can further, if you dig into the simulation softwares, some of them can be called as a general purpose simulators. Some may be called as physics based simulators, and some are industry robotic based. That means machineries, labor, robots, pulling on all those things, simulate something, do something, these kinds of things. And the last one is AI based simulators. All these will become the core areas in the coming years, and one has to know before we get into the any of such kinds of work. And general simulation softwares, here, if you take the first one, general simulation softwares, I'm just naming few only, need not be. Now the more number, even I have heard a name called Genie, means new names are coming, new things are coming. Even in the simulation side, we have Simulink, we have Simscape, we have Autodesk one has, they did with Auto something. Lots of names are coming, okay, which concentrate on design sides of it. Now, I'm not going to cover all those things, because to cover all the softwares of the today's market, for casting itself, we have a simulation. For other things, we have a simulation. Many simulations are there. But we fix it onto Gazebo, so which is extensively used in robotic applications. In the future classes, you may even get along with these kinds of robots and work using these kinds of softwares. And webbots, and again, you have a CopliSim. So this is one software, and I had given what you can do with these softwares in the 3 columns kinds of thing. Gazebo works with ROS. So as we are covering more on ROS, I think Gazebo, one thing you have to understand, and physics based sensor simulation you can do. It's an open source. This is an advantage for you. You need not pay. Just go to open source and download, and you can work on it. And the next one is Webbot. Easy for beginners. One can learn using this Webbot software. And built-in robots are there here, and which supports even Python and C++ programming aspects of it. So other youngsters, students, all of them can be given some task. So using these softwares, let them play with this software. You can get some output using them, and then you can take all those things and try to build as a product. So that's how you can do a product. Otherwise, it's very difficult. So you can use this. And Coplia is multi-robot simulation is possible here. Flexible is there. It also supports MATLAB and Python and other softwares. So it's one of the thing which you can concentrate. And a few are also classified under physics based. MATLAB is one. Nowadays, many of the institutions are taking MATLAB license campus wide also. And definitely you can make use of the MATLAB. In that, you can ask for a robotic also. So if you take that inclusion in the package, then your students can do a model development for a robot and then try on it. And Simulink is the along with MATLAB you can work with. Okay, PyBullet and other softwares are also which works on the physics based thing. And now in the physics based, if you take MATLAB and Simulink, control system design, it is the best thing. You can use Simulink and MATLAB to build your control and try different aspects of input and what are the output possibilities, and know the system level better, okay, before you go into any bigger level exercises. And also we have a academic and industrial use licenses in it. For academics especially, it is always a low cost modules. However, if you negotiate, they can give the industrial to academia also. If you buy that, even you can do some consultancy. In academia, what is the drawback is you cannot do a consultancy. Okay, and industrial robot simulation, RoboDK is there. Industrial robots, in the sense I am now concentrating on articulated and other robots which are integrated in the industries. Suppose if ABB robot you are introducing in the cell, then you may have to be very good with Robot Studio, ABB Robot Studio. So many industries in India are using ABB as a bots, Escava as a bots, and Escava uses, I think, RoboDK. So like that, you have to identify the simulation which the particular industry manufacturer has developed for its own robots. KUKA has developed for its own robot and called it as a KUKA Sim. So we have a KUKA Sim license with us. Around 10 license we use to train the student, and all of the trained guys will get absorbed in the industries today. That is the hot cake today. If you keep any of these softwares and train the students in those domains. Now, RoboDK, it's an offline programming. Industrial robot can be tried. And a few for AI and learning-based simulation we use. That is, SAC is one. OpenAI Gym is the other one we try to use as a simulation tools. And you can explore these. But widely in my 10-15 years of journey as a robotic guy, I think I would have trained more than 100 to 200 guys in the industrial robot segment, and they have their own industries. Some of them have their own factories as automation players, and some are there in a bigger industries like ABB. In ABB itself, I have my own students, up to 15 people who sits across different parts of the globe in the Robo Studio expertise level. So this is the one advantage. In the mobile platform, ROS platform and other areas, in the Wipro we have our student, and we have our Great Wall Motors, Dell, DTI, everywhere we have placed them. The only thing is we give them the bots and allow them free, giving the minimum basics. Now I have left all this training because coding is not my part now. The same thing I did with Arpita madam also. I have told how she has to take up her research, and she spent a lot of time in digging out some of the new things and publishing that and getting her doctoral degree. And a wonderful area to integrate with different departments and at different levels. Every academic people has to concentrate now, because India is going to pick up in a bigger way in these domains. Now I will be coming on to what is our invention. We have not chat like that, just we have invented many of the things, and we have tried many of the things in the market side also. We have invented a sensors to put it on the robots to know that when the robot is going to touch something, it can stop on its own. We have developed a polymer conductive sensors, and we have built a beading kind of an element which we supply to universal robots. So this is possible. Inventing on the material side, we have made a fingers, hand, robot arms, and beadings, smart jars. You keep a pads upon which you put a pad. You will be able to know what is the amount of water or what is the amount of ingredient which is present in the such containers. All these kinds of invention has been done, and even we have tried that in the tires, but we couldn't get a success because it's more dynamic, more rigorous. Application is more rigorous, and it has to withstand a hazardous situations, vibration levels, another thing. Our wiring inside the tire stayed only around 20 days. It couldn't stay for a longer time. So we failed there. Of course, failure and success is different part. Trying and inventing becomes a main part of the thing. And as I have told, one of the patent is on the conductive polymer side. I have done my 4 patents till now, and one on the conductive polymer side using as a robot beadings kinds of an element, which has been patented. And other one is smart cooking. We tried and patented. Of course, when we say a smart cooking, it is also a robot. We can call it as a robot chef. Of course, recent days you are hearing this in a big newses and mega events, advertisements and other thing, which is coming into market. But we have invented this long back. So proving the concept, patented it, and any Indian dishes of around 20 to 30 dishes can be cooked remotely from any place, like upma, pongal, kesri, all these kinds of things we have proved. Of course, parallelly, Stanford was doing a research on roti making. So we have started on Indian food making. I think Stanford started later, early itself, 5-6 years early. Now, to tell you what is the payback of all these things, many of the players are coming, and many of the dosa making machines are exported from Bangalore to another countries. Many of the food cooking machines are jumping the market in the near future. Roti making machine, Gujarati couples, the lady who studied from Stanford had came back to India and installed a plant near Chamarajanagar, which produces around 300 roti making machines in the Chamarajanagar, and it gets exported to all Arab countries and other countries where people can afford and pay more prices. Each machine sells at 1.5 lakh to 2.5 lakhs. A category of roti making machines has come into market. This is one our area. We have a patent in this. And the other one is remote laboratory. Madam said as an introduction while introducing me is, during the COVID, we were worried nothing is happening. Students are not getting practical hands-on skill. So we tried, and one of my researcher, I will work on this, and we started developing an electronic kits which can be worked from anywhere concept. So means we have created a kit wherein we could be able to test diodes, characteristics, forward characteristics, and characteristics. Completely you will get 1:1 graph which is generated through your mobile. You can be anywhere in the world. So this was the challenge which we had given. So like this, we had developed many of the inventions, and now these papers have been cited in high numbers across the globe, and few newer and newer things are coming even in the educational domain, even in the food domain. We ourselves now are working with a funding from DST for a cooking machine, which is affordable to the common man. So that means costing, using the costing kind of a thing. So, of course, these are our few inventions in the middle. We also copyrighted one algorithm for a medical application to move a robot for a particular disease, for a particular place of the human, when after he is laid on the what the medical bed they give. So image will taken and they'll be coinciding with all the X-ray and other scanning images, and then the robot will try to move to the particular part nearer to the part to assist the doctor. So this has been achieved, and that algorithm is made copyrighted in India, and that copyright comes to one of my student and my invention part of it. So other high-end thing, before we move on to other things, a lot of things can be done by you all, and the students are the best people. They can take up any challenges and they can do all the things. When we move on to the higher and higher level, there are many other things which you need to understand with respect to a robot. Object detection, tracking, mapping, autonomous navigation, obstacle avoidance, whether it is mirror or a wall, all these kinds of differentiation has to be taken. Lots of challenges will come, and these application requires an intelligent software which is established to communicate between all the subsystems and share the data from one process to another synchronously, so that you're able to monitor and do an application which is a deep learning aspects or large LLM kind of aspects. All this will be done. That is why I suggest AI is best can be taken with the word robot. Okay, when you say robot, AI is there. You have to go with an AI. So teaching with a practically using a bot or with a robotic concept, your students can also enjoy it and can make use of that. Now I'll move on to ROS, where this particular workshop, 5 days faculty development workshop, is being organized to make you aware on the platform tool called ROS, mainly on ROS2, and work with the software and also work with the other aspects of it to learn to it, complete integration and developing your own bots at your sites like that. ROS is an open source framework. Call it as a framework for a robotic application. And ROS provides a messages passing interface between the processors. That's the advantage. Need not be ROS. People are also using, I said, some new software. People are now trying to use that also. It provides many libraries, packages, hardware drivers, which helps to build our own robot for different applications. And it also supports C++, Python, and Java and other languages. So that's one more advantage for you. It provides many algorithms as an open source, readily available. It's a community, ROS community. Someone must have written and placed and you can pick that and make use of it. So for example, we need not writing detection and tracking algorithm. It's readily available. You need not write a mapping algorithm. It's readily available. You can pick and put it in the ROS and make it, use it directly. And ROS framework is integrated with third-party libraries. For example, if you're using a OpenCV to take some image and process it, yeah, ROS enables you to take the such thing. Not only that, even you can integrate some of the PLCs and do some more. I think that's also a possibility. Integrate for a robotic vision and PCL kinds of things, and even other integrators. Try, we can do. I think few more papers can be accepted by using that area. And ROS has a packages that can be easily reused with any robot, and that's why it is becoming more popular. Of course, there are some hitches in the ROS also. Hence, few people may have diverted from the ROS and made their own developments. We need not go into that level now. We are now only hooking on to the learning level. And ROS users are available everywhere throughout the world, and it helps you to clear your doubt and enables you to learn better. If you look at the ROS fundamentals, you have to learn file system level, some concepts, communication and graphic level something, and community level, you can get some information and make use at different levels. When you go to an understanding a ROS, you can take this architecture, file system level, then stack, manifest, stack manifest, and packages, wherein further you can divide it into messages, services, codes, like that. You can segregate them and put it in a orderly manner to pick and use it at the coding part of it. So you can also understand that at community or computation graph level, communication level, if you take computation level, nodes, master, and parameter servers, messages, topics, services, we call it as bags. All these will be discussed in the future classes, and you're going to work with different of all these ROS node. What is a ROS node? What is how to create a node? How to kill a node? All these concepts you are going to discuss. And I think I'll just go through fast. I think my time is up. Anyway, these are the few basic commands. You're going to use it in the future days. Few of the commands I had given to print the message, to say find the topic, to display the publishing kind of a thing. All this is possible, and you are going to practice that in the future days. Community level, you can get mailing list, wiki is there, answers, ROS answer is there, repositories are there. This is an advantage and helps you to learn easily because you are in the community, you are in a family. So your son, daughter, all how they help the family. So like that, the community people in and around you will become your family members, and you can be with your family to learn better and better. And one of the good tool that you need to do understand is these RVs also you can use, Gazebo also you can use, few of the tools and their users. Just I have showed, of course, how the communication will happen and from a master to nodes kinds of thing. Prerequisites, I think madam will tell in the future. You need to already given through the messages, Ubuntu, you install all those things they have told. Yeah, you know this. Few of the commands I have listed. How to create a ROS workspace and package I had given. You're going to practice this. No need to tell us a presentation slide. Of course, you also have a some of the readily available demo thing that you can pick up from the thing. one of the best thing is few videos, lectures I can send you if you want to learn this demo part of it. Gazebo also you have to learn, install a package, and you have to know how to install a camera part of it, and how to install other things. Now I'll be showing one of our work, which I don't know whether we can play it or not. It is a work done along with this ಇಲ್ಲಿ ಬಂದ್ಬಿಡು ಹೊರಗಡೆ ಇದರಿಂದ ಅಲ್ಲೇ ಪ್ಲೇ ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ ಇದೆರಡರಲ್ಲಿ ನೋಡಿ ಡಬಲ್ ಕ್ಲಿಕ್ ಮಾಡು ಬರಲ್ವಾ? Okay, let me come out of this slide and I'll try to show a video for you, wherein we have developed a autonomous vehicle for within the Wipro campus. Our students were the interns during the development of that bot. I had that video, and also we have developed one at NIE, which we have made to rotate in the corridors. That videos I have. I'll come out of this and try to give you video if possible. Mysuru. This is the center at NIE Mysuru, which is located in the main building, which is before independence, or 77 years old building. Second floor, we have a robotics center, from where even many of the researchers from GSSS have worked on it. And one of our students is demonstrating a humanoid put on a wheel on the corridors. Just you can watch. Yeah, I hope I have done my session. I thank all the participants for listening to my introductory session on the robotics. I'll call Arpita madam.
Yeah, thank you, sir. Thank you so much. Participants, any doubts or any queries?
Good
to the
evening, sir.
resource person?
Yeah, good evening,
Hello, sir.
Kiran.
Sir.
Yeah.
My name is Kiran, sir.
Yeah.
I'm pursuing MTech
Kiran.
in robotics and AI. Sir, you have said that for autonomous and multitasking, the Raspberry Pi has a limitation, right, sir? So, for the
As a
autonomous,
limitation
which
means
is
a complexity.
yeah, what is the best hardware, sir, for the autonomous mobile robots?
Yeah, we
You can
have
use for the project.
we have used just Jetson boards, Pi boards also we have used. Even with Pi, we have done some of the work. But we have observed that it is becoming heat sometime, and then we have worked on Jetson boards. And even Infosys has developed some controllers along with Mini. So our institute is supported by Infosys because Narayan Murthy sir is an alumni, and we use those boards also.
Okay. So for the project, which is the
Project you
web
try with
regarding-
Pi, that is more than sufficient, I think. With the Pi, you can go up to a navigation and in a particular room environment and do a small kinds of thing.
Yeah.
Even
Okay,
with
sir.
Pi,
Got
we
it.
tried up to navigating through lifts also. That means Pi is more than sufficient if you are a student and if you have a controller. Otherwise, if you go to other boards, you may have to invest around 40-45K on the board itself. Sometimes you can buy a mini PC and use the mini PC and use Pi or something like. If you have a money, how you are going to look towards your project and what is the things that you are going to do. A simple project with Pi, more than enough.
Yeah. If you want to integrate camera, LiDAR, is it sufficient?
Yeah, Pi can do that.
Okay. Yeah. Okay, sir. Got it, sir. Thank you so much, sir. It was a wonderful session.
Any other queries? Okay. Okay. Prakash sir, thank you, sir, for delivering an insightful sessions on introduction to robotics and robot programming. Actually, I take this moment to thank Dr. Prakash sir for facilitating me to carry out my entire research work in his lab. Thank you so much for that, sir. I'm always grateful for that work.
I'm very happy because after you, one time you were very nervous and now you are so confident and you are taking the region on. So this is the best thing a teacher can have.
Thank you so much, sir.
Thank you. I'll end my session.
Yes, sir. Okay, moving further, I would like to invite Ms. Sumana, Assistant Professor, Department of CAC AML, to introduce our next resource person, Mr. Raghunandan B, CTO, Synexia Global Solutions, to the participants.
Thank you, ma'am.
Okay, thank you, ma'am.
It is my privilege to formally introduce next resource person. Mr. Raghunandan B is a seasoned technology and operations expert with over 16 years of professional experience across manufacturing, information technology, education, and product development with strong expertise in AI, IoT, robotics, and digital transformation. He holds a bachelor's degree in electronics and communication engineering from VTU and master's degree in signal processing from SIT Tumkuru. He began his career in the electronics manufacturing and R&D sector, working with reputed organizations such as Vinyas Innovative Technologies and L&T Technology Services, where he contributed to design for manufacturing practices, digital image processing solutions, and quality optimization initiatives for defense and industrial products. He has also played significant leadership roles in academia and institutional operations, serving as assistant professor, placement officer, and head of operations. In these roles, he successfully implemented ISO 9001:2015 quality management systems, led large-scale recruitment initiatives, and trained over 4,000 students across Karnataka, contributing to improved placement outcomes. In the EdTech and immersive technology domain, he was associated with Holosuite, where he led R&D and delivery of robotics and AR/VR-based educational products, fostering strong industry-academia collaborations and managing end-to-end product development and technical training programs. He has also served as Director and Chief of R&D at Vaonsi Technologies Bengaluru, leading the development of ERP system, IoT solutions, and smart automation platforms with a focus on AI-enabled and Industry 4.0 technology. Currently, he is associated with Synexia Global Solution, an AI and robotics startup where he is actively involved in technology development for intelligent automation and next generation robotic systems. We are grateful to Mr. Raghunandan B for kindly consenting to deliver today's session on Linux for robotics and ROS2 basics, workspace, packages, and nodes. This session will provide participants with a strong foundational understanding and practical clarity that are essential for modern robotic system development. Once again, we are warmly welcome Mr. Raghunandan B and invite him to kindly take over the session and share this valuable knowledge and experience with us.
Yeah. Am I audible?
Yes,
Hello.
sir.
Yeah. Thank you, Professor Sumana, ma'am. Okay, so it's really an indeed pleasure to be a part of this session and to kickstart with the basics of robotics, that too robot operating systems. And really, I would like to thank the management of GSSS and Principal Sir, and even the coordinators, especially Arpita ma'am and Manju Prasad sir. Okay, so for hosting this entire event, and I can see the participants almost crossed 100, so have been continuously listening to the sessions even from past 1.5 hours. Okay, so I hope this will continue because I would like to carry forward all the same journey for the next 1.5 hours with the practical hands-on, right from installation of robot operating systems in the Linux platform, and as well as creating the basic workspace to start your ROS development journey. So that is what the entire insights of today's session is all about. Manju Prasad sir, could you please extend me to share the screen?
Yeah, sir.
Thank
Now
you.
you are a host, you can share the screen.
Yeah, thank you very much, sir. Thank you very much. Okay, so let me share my screen. Yeah, I hope screen is visible.
Yes, sir, visible.
Fantastic. Yeah, so coming to my background, yeah, already so a brief insights has been provided. So very importantly, we have just kickstarted this AI journey with a name called Synexia Global Solutions, where we to provide AI automation solutions, including robotics solutions, customized solutions for various industry automations, especially. So that is what the new journey has begun for us. Okay, that is one thing. So with this context, so I would like to start the session now. So really, I would like to thank even Dr. R Prakash sir. He's one of my mentors. Okay, so has helped me a lot in my career journey, especially. Okay, so especially in building the knowledge about in the field of robotics as well. Okay, so anyhow, the context has been set by Professor R Prakash sir, and now in continuation with that, so we'll have a hands-on session. So I hope all the participants have received the basic details to set up your requirements related to the Linux, the Ubuntu platform, and as well as installation of ROS2 environment on that Linux. So if you have even created the virtual machine also, it is fine. But of course, I'll just skim through the basic requirement. If you have any doubts, so please raise your hands. Okay, if you are fine, so please raise the thumbs. Okay, so in the session, so I think I'll get an acknowledgement so I can move forward. Okay, so yeah. Yes, I'm getting, yeah, yes, Professor Vicky, I think. Yeah, Mr. Vicky Patel, I think you can just can unmute and you can ask if you have any questions, doubts.
No, sir.
Okay, fine. Great. So before we start with, I would like to give you some knowledge. So why Linux plays a very important role, especially in development of robotics applications. So that is what the main concern. I'll start with that, and then we'll move on to the actual ROS thing. I'll take 2 to 3 minutes, not more than that. Okay, so the modern robotics, how this robotics applications in various domains are placing a very crucial role. Correct. So going forward, so in the streets of even in India also, so you can see various autonomous robots that wander, and so development of such systems, definitely it is not easy task. Correct. So there are a lot of contributions towards even that developments also, and so even in Western countries you can see already the people have been implemented various such robotics applications in various domains. So right from commercial applications till industrial applications, not even space vertical has not been left out. Okay, so coming to this part. So when you talk about modern robotics, definitely real-time processing and even processing the multi-sensory data, network communication, computation related to artificial intelligence and machine learning, and managing the hardware. It's not an easy task, correct? And definitely we need to have a distributed control and computing system. So that's why Linux is one of the very good strong backbone, especially in developing these kind of applications. So because this gives us a leverage, especially to have an open source flexibility and real-time kernel support, and very importantly, high performance and security in terms of networking and compatibility towards the hardware. So whatever the, especially for the experimental purpose, if you take any open source electronics today, so right from Raspberry Pi, whether it is Arduino or whatever it may be, so even it is very much compatible. Okay, that is one thing, and it is platform independent. Whatever the softwares that we use, it's open source. Since it is open source, so whatever the even to the level of business, you can develop the applications and so on. So almost all industrial robots, autonomous vehicles, even drones, whatever it may be, so any kind of mobile robotics. Okay, so right from medical applications till space applications now, so Linux are in the application of this robotics, especially using in the Linux platforms, are very, very popular now. So, and people are contributing more and more towards the development of these kind of APIs, softwares, and so on. Okay, so and even hardware wise also it is supporting a lot, and since it is very much secured, so even most of the servers, if you want to build servers also, especially in terms of security related things, so Linux provides a very good flexibility. And concern to the distributions, especially, so right from the desktop operating system, that is Ubuntu long-term support, till even any low-cost hardware, so we can find the usage of this Linux operating systems. Okay, so you have seen various distributions right from Ubuntu, Debian, even for an example, Raspberry Pi operating system. It is built on Linux itself, Ubuntu core. And even if you take any open source boards, for example, NVIDIA boards also, so they also use this, and it is also available in various platforms. Suppose if you do not use any GUI related based application, if you want to work only on the command line interface where GPU usage is very, very less, even that also supports by Linux. So that is why, so it is very, very popular, especially in the field of robotics. This plays a very, very important role. Okay, so moving forward, so now let us come to the part of robot operating system. So people, even from 2010, right from the inception of this ROS. Okay, so earlier stage, I know, so we have various flavors related to this, and this particular software specifically developed for creating the applications of robotics especially. And of course, it is not a standalone operating system. It needs the support of some other basic OS like either Windows, Mac, or Linux. And since there is a huge community, as even the previous speaker has told, so because of this large community support, so we can develop an application very quickly, such that already the libraries related to various integration part of the sensors or whatever it may be, so has been already built, and only the newer part is only under in the research process. So now if you want to build any applications or industrial products, okay, so this definitely provides a very good platform, okay, so to use this particular operating software, that to develop robotics especially. Okay, so going forward, so in the all the industries, especially in India, is also looking forward to automate the entire processes. So now, even if you remember, in 2008, Bajaj is the first company who has completely created the automation, implement the automations through the collaborative robots. Okay, so now from 2008, now various industries are also adopting these technologies, especially, and there are a lot of huge demand, especially in the career aspect also, and as well as research purpose. So there is a greater mileage as well as in upskilling your to kickstart your career, especially in the domain of robotics. Okay, and very importantly, so this ROS, since Linux is one of the greatest leverage, especially to use to develop any kind of software applications. On top of it, ROS also plays a very important role and is also open source. So that is what. And and another features coming to ROS, if I want to mention, so it is having a huge global community, and it can operate, it can work in different multi-domain applications. So like indoor and outdoor, you name the domain, so we can use robots. So when you say robots, definitely ROS comes into picture. Okay, and since it is having multiple platform support, whether it is Windows, Linux, or Mac, so that is, once again, it is platform independent, and once again, it is 100% source, commercial friendly, so no need to pay anything. And it is, of course, it's open source licenses. You can create your own applications, and you can label it, and you can sell those products also. Okay, so currently the current version of ROS so is ROS2, so which is very, very popular, which is huge in demand, especially in developing the industrial application or whatever the verticals is now mentioned as a part of my conversation. Okay, so going forward, yeah, so as of now, we can see there are the two types of versions. One is ROS1 and ROS2. So more specifically, if I want to give some information, so I think at the previous session, at the end, there are list of commands that has been also depicted on the slides. So it was mentioned that various commands are mostly related to ROS1, that to ROS1, and currently ROS2 is in very popular. ROS1 already the libraries and the packages is in obsolete stage. So from 2017, I think, sorry, 2022, it got stopped. So now ROS2 distributions is in progress. So currently, I'll also show you the different types of ROS2 versions that are currently in use. And in today's session, so I'll be using ROS2 itself, and to have an hands-on. So I think everybody have created installed this ROS2 repository, and install the entire ROS2 package on Ubuntu, that to 22.04 LTS system. Okay, so if we want to give some core differences between ROS1 and ROS2, of course, 2010, this entire open source community related to this robot operating system got started. But ROS1 till 2020, it was active. The last ROS1 version was ROS1 Neotic, that was in 2020, it got started. It was an LTS, once again, software, and it was available till 2025. Okay, so ROS2, it got started in 2017 especially, and you can see various flavors, right from Humble, Jesse version, and even Iron version also. It's not a long-term support. So currently it is available in active development version itself. So the main architectural wise difference is ROS1 is purely a centralized version. It is not a distributed network. So that was one of the disadvantages related to the ROS1 development compared to ROS2. So since ROS2 is a distributed data distributed system based kind of development, so you can see the usage of ROS2 in various applications. Okay, that is one of the major advantage, the usage of ROS2. Okay, so coming to the industrial automation part, so ROS2 is only limited for only research purpose and developing some applications only on the research table. So not for the industrial applications, but ROS2 is specifically and typically developed for industrial and automation applications, right from factory automation till medical robots development. So that is what. And coming to the programming languages that are used in the development of ROS1 or either ROS2. So very popular programming language, so is Python. So very importantly, so everywhere now, even the flavors of embedded versions of Pythons are also available. So in the same way, so ROS1 was typically Python 2 and Python 3 were dedicatedly used, especially in the development part, and C++ up to version 3 was used. But ROS2 is concerned, Python 3 is only one support that we get. That is the latest version. And you know, Python 3, what is the advantages related to 1 and 2 versions. And C++ version flavor is also available in ROS2. That is C++ 17. That is it started with that version of C++, and especially the build system is concerned. So if you remember the last previous session slide, so there was some build system called as Catkin. Okay, so the same thing has been changed to Colcon in ROS2. So this is what the basic thing. So that is what we'll be using today as an hands-on practice for especially in developing the applications, especially to setting up the environment today. So that is what we'll be learning. So I hope I have given pretty good information related to difference between the ROS1 and ROS2. Okay, so coming to the various flavors, you can see here. So if you even go to the ROS website, you can see this kind of logos. So as I mentioned, today I'll be using not only today, so entire series of the training program. So we'll be using ROS2 Humble Oxable. So that is specifically developed for Ubuntu 22.04 LTS system and as well as Windows 10. Okay, that is one thing. And ROS2 Jesse Jalisco, it's a latest version. So 2024 they have launched this, and even 24.04 that Linux system we can use it. Okay, so your entire training program hands-on session is only limited to 22.04. Of course, since it is having still long-term support till 2027, so definitely you can develop various applications by learning ROS2, and there is no changes. And whatever may be the versions going forward, if you learn the basics of ROS2, that to Humble Oxable, okay, so you can upgrade yourself with any other versions also, right from Humble Oxa. Okay, so that is what. Okay, so in our system, the distributions, ROS distributions, especially Humble Oxa, so that is LTS system only we'll be using. So rather than it is mentioned here, Kilted Kaiju. So this is what it is not a long term, it's a short term release, I think. So better to use for any applications, any research purpose, try to use only LTS systems itself. Okay, so this is where the release date and so end of this distribution is available. So Jesse Jalisco, the recent one, till 29 May, so it will be available. Humble Oxable, which we are using, so till May 2027, so we'll get support related to this ROS2 distribution. Okay, so coming to system requirements, I hope so with minimum Wi-Fi systems, any compatible to install Ubuntu 22.04 is suitable to run this application. So now I am using I am using the virtual machine here. So I have installed 22.04. I hope you people have also created the virtual machine, and also you have installed Ubuntu 22.0.4 and as well as ROS2 distributions. Okay, so if not, you can raise your hands. So I'll just go through, I'll just skim the installation procedure related to ROS, not with respect to the virtual machine. Okay, so even I have shared a video by how to install a virtual box and as well as creating a virtual machine for Windows 10. Okay, but I am using Linux-based system on 24.04. I have created VirtualBox. I've installed VirtualBox on that virtual machine. I've created 22.04. Okay, so let us skim through the system. I just wanted to reshare my screen. Let me stop sharing. So let me directly go into the system. I'll just open my Linux platform itself, 22.04, the virtual machine, which I have created. So I want every participant here to be ready. You can just open and let us start together with an hands-on. So I'm sharing my screen. So this is the virtual box which I've used, and I have already installed Ubuntu 22.04 here, and also installed ROS2. I'll just skim through. If there is any questions, you can just ask me. I think Professor Geeta, I think raised her hand. So, madam, if you have any questions, you can ask me, or you can type the question. So I'll just give you basic insights. So because let us not waste time, that's the reason why we have shared this information in prior. Okay, so very importantly, there's a link which has been shared also to start to complete your setup of ROS2 Humble Oxa, Humble Oxbel, okay, on Ubuntu 22.04. So first basic thing is you have to set the locale. So very importantly, it should be UTF-8 system. So basically Linux will be by default, it will be in this UTF system. If not, you need to change. So this is what the set of commands you need to use. Okay, so to set the local. And very importantly, you need to set up sources also. So in order to install the repository. So okay, so software to install the entire ROS system. So that is why these two commands are very, very important. Let me zoom in, okay, if it is not visible. Okay, so download the package, ROS2 package especially, and so whichever the repository which you have created here in the previous two command lines. So if you download it, once you download, so you need to update and upgrade the entire Linux based packages. So sometimes you may get warning. So during my installation, I didn't get any warning here. Okay, so it is not visible. Let me reshare. Is it visible now? Yeah, this link has been shared. I'm just skimming through whatever the basic setup you need to have. Okay, so I'm not showing all this setup again because we have already shared this information to you to keep it ready for the hands-on. Okay, so very important. I'll once again reiterate. So first you have to set the local system, that to UTF-8 base system. Once it is done, you have to set up, you need to add the ROS2 repository to your system. So that for these two commands will help you to set up that repository, and then you have to download the ROS2 package, the main global installation software. So once it is done, you need to install those packages. So meanwhile, when you're trying to upgrade, if you may get warning. So I didn't get during my installation. I hope so nobody didn't get this warnings also. So once it is done, I think you can directly start installing desktop mode of ROS Humble. So rather than base system. Okay, so ROS based, if you try to install, there won't be any GUI, graphical user interface. So better to start with desktop installation. So this is one thing. So if not, so try to install now quickly. And so this is what the command we use: ROS Humble followed by, so whatever the packages if you want to install related to the ROS. So this last third word will going to change. So that is what. So I have installed a desktop in my system. Once it is done, you need to set up the environment. So that is very, very important. So for that, you need to source this bash file, okay, in the system. So for now, I'll just open the terminal. So I request everyone to open the terminal, and then let me, I think I'll just put at this stage. Just a moment. So let me open the terminal in Linux. I think if you are comfortable, so to open the terminal in shortcut using keyboard shortcuts, so Control-Alt-T. So now you can open the terminal. You can just check. See, I have installed the ROS. I have not sourced this setup.bash. So I want to show once you download the repository, once you install, so where this actual ROS2 will, the repository is available. So now to check whether the ROS2 is active or not. So I'm just running this command. So first command is ROS2. So now I'm just trying to enter. It is showing it is not found. Okay, you can also check in your systems wherever you have installed. Okay, so it is available here. So let me show you that where it is available. Okay, and so I can just go to this particular path. So CD, it's in OPT. Okay, so if you just enter, if you just list out all the files under this OPT, you can see ROS, this distribution which has been installed here. So go and check here. If you just once again list, you can see the version. Okay, humble version of ROS2. And so once you get inside this, okay, if you just see, you can see there is a bash file, setup.bash file. So you need to source this. Okay, I'm trying to source now. So use the command called source, so which is already been mentioned here. So this is what the basic environment setup. You need to source that source the script file, bash setup.bash file. Okay, so before you start to run any ROS2 commands. Okay, so that is what I'm doing now. Okay, source setup.bash. Okay, so you can see it is done. So now, so if I just open another terminal and if I run, sorry, I have to run here itself. So if I just type ROS2, and you can see it is detecting the ROS2 commands. Okay, so but one thing is, every time when I open the new terminal, I cannot run this. So for example, I opened this new terminal on the right side. Again, it is showing ROS2 command is not found. Each time when I open new terminals, I need to source this bash file. So to avoid this, so let us include this entire path. Yeah. Sorry, I think suddenly my system got restarted. I hope I'm audible.
Yes, sir, you're audible.
Yes.
You can share the screen.
Okay, I'm sharing this.
Yes, sir.
Fine. I hope everybody have started to test the installations in your respective system. So please proceed with that, and just let me open my VirtualBox meanwhile. So far we just discussed whether your installation is working or not, and so using this ROS2 command, so you need to source this setup.bash file, so which is very, very important. So if you source it, so then you can able to use it. So in order to avoid this manual sourcing of this particular script, so let us include the entire path of the setup.bash into bash rc file. So that is what the next thing we would like to do it now. So I request you to open the terminal. Inside the terminal, So please type.
Raghunandan sir?
Yeah, I'm sharing.
Okay, sir. Okay.
Yeah. So this is what we were discussing. So we need to open bash rc file. So I'll just try to give the command. So let my machine VirtualBox let it get open. I'll reshare it. So I request you to type gedit. I'll just share that command also in the chat as well.
Sir,
Yes.
in my system, I already installed ROS,
Yes.
and even if I start a new terminal and I type ROS2, it will start firing on. So I do not need to do this gedit thing, right?
No need to do.
Because mine is already set up in a way.
Yes, it is fine.
Okay, sir. Yes. Thank you.
Sir, excuse me, sir.
Yes, madam. Tell me.
I'm having mobile. Shall I open it in mobile, sir?
No, how can you open, ma'am? You have to create a basic setup using your laptop. So if you have installed Linux Ubuntu 22.04, so on top of it, you might have installed ROS2. That is what just now I showed you the installation steps. Okay, so post to that. Yeah.
I'm having only mobile. I'm not having laptop. What can I do, sir?
Yeah, just listen to it. So once you get into your machine, you just try to handle it, because workspace creation is the main motto of this particular session. So once you create the workspace, it is very easy for you to create any program related to the ROS packages. Okay, so I'll also teach you how to create packages and even notes as well by this end of the session. Okay, so that is what the main agenda of this session. So I'm resharing my screen.
Okay, sir. Thank you, sir.
Yeah. Yeah. So the main problem is I cannot run this. So that is what it is showing. So I need to source that bash file, so which has been already installed inside this OPT folder. So wherever the repository got created, so I need to include that entire path into my bash rc file. So to open that, use this command gedit. I already shared this in the chat box. Okay, you can use that. So use this bash rc. So let me zoom in for the clarity. So gedit bash rc. If you just enter it, so you can see the file bash rc file will get open. So just enter the use the enter button. At last, you need to link. You need to use the same source command and enter that path wherever that setup.bash file was there, that script file was there. So that needs to be included here. Okay, so let me see where is that file is available. I think it is ROS and it is humble, and then setup.bash. Okay, so save this, and just to re-verify, I'm just opening another terminal. Okay, so opening another terminal to just verify the path. Yes, so this is what the path. So opt ROS humble setup.bash. So save this and then close this. Okay, and you once again run this command, source bash rc. Okay, so now if you run ROS2, so it will detect the command of ROS2, automatically. Okay, so why we need to do this source? Because already I have opened this terminal. So once you try to open the new terminal, automatically this bash rc file will run from the backend. So no need to explicitly run this setup.bash file. So all this ROS2 commands will be active, so you can use those ROS2 commands. So once again, I'll show you. I'll just close this since I already added this setup.bash script file into the bash rc file. If I open any new terminal, so automatically ROS that path will be executed, and directly you can use any ROS2 commands. I hope you have got the clear picture now. Okay, so now moving on. So I think if you have done with this, so you have installed ROS2 successfully. So if you are getting any errors at this point of time, at this point of stage, so I think there is some errors while you're installing during the installation of ROS2. So follow the steps which has been shared, and then you can proceed with that. So let me clear this particular commands which have been used. So now let us move forward. So what we are thinking is, once this is the basic setup, that is what we need to do. Now suppose if you install any ROS2 packages, so because I have already installed desktop version of ROS Humble, so basically it also comes with the various demo programs also. So now just for the sake of interest, how to execute some nodes. So let's see whether the demo programs has been installed or not. So let us run those programs here using same ROS2 commands. I'm using ROS2. Okay, so I want you to note down, otherwise I'll share this command line commands in the chat box itself. So ROS2 is the main command, and then so we have to use the main command to run the executables. So very important. So there will be a package already been installed once you install the desktop version of the ROS. So now I'm going forward for the available demo packages, so called as demo underscore. So if I use double tab, you can see the auto completions also. If you once again tap double tab again 2 times, you can see. So demo underscore nodes, there is a CPP packages available. There is also Python packages available. So let me use CPP. Okay, so inside the CPP, so if you want to find the executables, okay, so you don't know which program I need to run. Okay, so just once again press 2 times tab. Okay, you can see the list of executables that are available inside the demo CPP package. Okay, so I'm using this Talker. Okay, so you'll come to know what you mean by this Talker executable, what this will do. Okay, I'm just running this. Okay, so press enter. Okay, so once you start running this command, ROS2 run, then package name followed by, I'm just killing this node, ROS2 run, package name and the executable name. Okay, so this is the standard format syntax you need to follow. I'll just copy and also paste this in I'm just zooming. People are typing the message. So this is the command you can run here. So ROS2 is the main installation which you have done. So you have to use the command run, and this is the package name. So demo underscore nodes underscore CPP. So then the executable name is called as Talker. Okay, I'm just rerunning again. Okay, so now this is a node, which is nothing but a program, a ROS2 program itself. So now it is trying to publish some message, and you can see there is a log information also with timestamp, and it is also displaying a message hello world, and it is also how many times it is displaying. So this is what the demo program that is available inside the installation. So what I will do, I'll also open one more terminal. Okay, so let me use another executable. Okay, so similarly, I'll just use the same ROS2 run command, and again demo underscore nodes. So now instead of CPP, I'll use Python package. Okay, and then instead of listener, so there is a package called instead of Talker, there is a package called listener. I'll use that executable. Okay, so let me use this listener. Let me enter. So now if you see, so whatever this particular node, which is called as Talker node, which is publishing that information, so that has been received by this listener node. Okay, so I request everyone to try this. Please try this at your systems. So this is the basic demo already available in the installation. Okay. So with this, so I would like to also show it to you. So how this communication is happening between these two nodes. Okay. I'll come to the part, what do you mean by nodes, how to create a node and so on. Okay. So we'll quickly cover that also. So I'm trying to open one more terminal also. So each time when I open the terminal.
Sir, I want to ask one question if it's possible.
Yeah, please.
The talker is a CPP, means it's a C++ file.
Yes.
Right. If I want the listener to be a Python file, can it still listen to the same node, or it has to be configured in a specific way?
No, both are different. Okay, but that is the beauty of ROS. So even if you have run, the packages are of different languages. So now we have created one package in C++ and another package on Python. So you are able to communicate using the global installation. So that is what the flexibility that ROS will provide. That's the reason why I have taken these two different examples.
Okay.
Because
there will be no communication gap between any languages. Like C++ and Python will not like discriminate each other. The language is different, so I can't communicate with it.
Nothing. See, whenever you try to send any messages between two nodes, okay, so that is what, for example, when you create a system, robot system, so there will be a heart of the system, so it's a controller. So controller will be integrated with various devices. It can be an input device, it can be an output device. Usually a sensor will be act as an input device. Sensor will try to send some data, so it can be a different format where the data will be received by the controller. So finally, when it is received to the controller, it will be in the standard format where how the controller can able to modify the data or actually process that data. So finally, it will send the information to the actuator such that robot can navigate. Okay, so in the same way, irrespective of the language, so you can have a successful communication between any of the two packages, even you have written in different languages also. Okay, so I'm just now using another command here, rqt_graph. You just wanted to see the graphical interface, how these two nodes are connected. Okay, so I'm just executing this. rqt_graph is the command. Okay, so this is what the GUI. Once you refresh this here, there is a refresh button here. If you refresh this, you can see there is a node depiction here. So the elliptical shape representation are the two different nodes here, and you can see there is an arrow. So this is where the communication is happening from talker. So information is sent to the listener, and it is not directly sent, it is sent through a ROS topic. So this will be covered later sessions. Okay, so directly two nodes cannot have a communication, so there will be an intermediate person called as topic. Okay, so through topics only we have to have a communication between two different nodes. Okay, so for an example, so suppose if you have observed or not, when I executed this particular program, it is still showing that it is publishing and it is listening here. So this particular node, which is a Python package, it is trying to subscribe the information which has been published by the first node, that is talker node. Okay, so that is what this particular node is acting as a publisher. This is acting as a subscriber. Okay, so going forward, you'll understand the basic concepts related to how to create a publisher node and how to create a listener, similarly subscriber node also. So before that, very importantly, how to create a node is very, very important by creating a workspace. So that is what we'll be learning today. Okay, so and another important point. So now I'll try to kill any one of the node here. So I'm just trying to kill, and but the listener node just not stopped here. It is waiting to receive the information. I'm just trying to enter using my keyboard here. It is still waiting and it is open, and it is awaiting to receive the information from the node, that is talker node. So once again, I'll try to publish the information by running this cpp talker executable file. So soon I start to send this, so this listener starts to receive. Okay, and if I once again kill this particular node, it stops receiving. And now if I go back to the RQT graph and if I refresh this, and it will show only active node, which is listener available. Okay, so this particular UI representation will help you to debug if there is any problem, right? For example, one node is trying to communicate with another node through a topic, via topic. Okay, if that is not happening, means RQT graph UI will help you to actually debug. So whether it is properly communication is happening via the respective topics, okay, or not. Okay, so yeah, one more example I would like to show before we go ahead with creating the workspace. Sorry. Okay, so I'll just close this. So there's also one more available installed demo program available inside the ROS2 installation. And let me clear these two. So let me run this ROS2 turtle sim package. Yeah, turtle sim. So I'm currently using this turtle sim node. Okay, so I'm launching this particular executable here in one terminal. So I request you guys also follow the steps what I'm trying to do. I'm just copying this and this pasting in the chat itself. Yeah. I think, sorry, to kill the node, I forgot to mention. So Control C is the command to kill the node. If you press the active terminal, click on it, and then use Control C keyboard shortcut. So to kill that respective node. So I've just shared. So try to run this. So this executable, if I run, automatically you can see a UI that got created. So node, this is one of the node actually. When I use this package called turtle sim, so there is a node called turtle sim node. This will launch this UI. So therefore, node is not only restrict to just send an information. You can also create a UI. You can also launch UI. You can also launch web applications and so on. Okay, you can. So there are a lot of other applications where whatever this node can do. Okay, so this is one example. So where you can also launch a UI with the help of a node. Okay, so similarly, I'll be using another executable here under turtle sim itself. So ROS2 run turtle sim, and this time I'll be using turtle teleoperation executable. Okay, so this is another node. So just now it got launched now. So now it is telling you can use your arrow keys of your keyboard. And if you use that arrow key, so while using this arrow key, this should be active. So mouse click on this terminal and then try to use your up and down, right, left arrow key. You can see the UI, whichever the turtlebot available here, it is moving. Okay, so try this at your systems. So this is one of the package, turtle sim package that is available. So you can learn various concepts, especially the mobility, creation of mobility of a robot. So with this just UI implementation itself. Okay, so there's one of the UI available in the installation itself, demo installation. Okay, under ROS, any ROS framework versions it matter. Okay, so I hope everybody are following. Websites, I think Mohan sir is asking. Sir, I think there are a lot of video resources available on YouTube also. You can try to find it. So the very best thing is try to follow this we have created in a structured manner. So each and every resource persons will help you to guide you properly. With this basic knowledge, you can definitely upskill yourself and trying out various other applications as well. And there is no limitations for your imagination. You can do wonders. Okay, so this turtle sim, they have created this UI. So with the remembrance of the actual turtlebot that they have built. So this is the first logo creation robot turtlebot that has been created long back in 1980s. Okay, so with that, for that remembrance, so they have created this UI also. So that is available in ROS2. Okay, and now also if you run ROS RQT graph, you can see the connection between these two nodes. I'll just refresh and I'll just refresh 2 times. So you can see, so the communication between these two nodes, I think it is quite complex now compared to the previous example. So turtle teleop, this is the turtle sim. So this is the UI node. So this is the actual operation that has been taken care. And you can see the various communication that is happening between the topics. There is various topics that has been created here. Okay, and similarly, there is an option here. If you click on this drop down next to this refresh button, if you just also click nodes and topics, active nodes and topics to be shown, which are active, so you can see. So the bounding boxes which are in the square shape, these are all the topics. So in the elliptical shape, these are all the nodes. Okay, so nodes directly, they cannot communicate each other. It will communicate with the help of topics. So that is what the meaning here. Okay, fine. I hope, I think if I just try to quit this, okay, so you can see the active nodes if I refresh. So whichever the node which is active available. So there is only one node which is active here. I hope you guys have tried this. Okay, so try to use this many number of times, especially to well versed with the commands, so that you will be going to use further, because all this command line interface only. So going forward, rather than running a single node, each and every node you have to write one command. Rather than that, you can create a services also. So with one service line, you can run both publisher and as well subscriber entire robot system together. So where you can build a separate nodes for each and every sensory and actuator systems. And for example, camera, I have integrated LiDAR, I have integrated 2 different systems. So you can create a separate node for these 2 and separate packages also. Okay, so your different types of cameras you can use under one camera package. You can have 3D camera, similarly mono camera, and so on under one package. So like that, multiple nodes can be created under one package, and even those nodes can also have dependencies in between also. Okay, so that we'll discuss going forward. I hope any questions, if you have, you can just ask so far.
Hello, sir.
Yes,
Are you getting my voice?
yes, sir. Tell me, sir.
You see, you are telling node. Node means you are trying to open and show the true terminal, and you are able to run and something running. Okay.
Correct.
Now you are telling both nodes cannot talk directly, and you are telling it can throw only through what you told that through.
There is a concept called as ROS topics, sir.
Topic. So
yes,
actually,
yes.
what is exactly topic? Topic means exactly what? Is it a separate package inside? So through that it can go like that and come like that. Is that it?
See, this is a standard format they have created under ROS to have a communication between any nodes or any 2 different packages. Okay, so here, as in the first example I have depicted, I have displayed the 2 different nodes of one is Python based, another one is CPP based. Okay, so executable wise, both are different languages. Okay, so when you try to communicate between those 2, okay, so there are only some information which has been passed in a separate format. Okay, so these things are handled by topics. Means what kind of message you need to send and what kind of message that has to be received. Okay, so here when you're trying to send, so that particular node should be always, it should be a publisher. It should always try to publish that information to the external world. So this external word will be captured by ROS topic. So you need to define type of messages. For example, when you say about type of messages in your programming languages, there are various types of data that can handled by variables. For example, integer data, real data, strings data, and so on. Okay, and there are various types of data structures are also available. And when we talk about robotic system, so you can see there are various even geometrical informations also. So when you talk about for an example of ultrasound sensor, so the numerical data that we're going to push, so that numerical data also, it will be in the real format. So now when you try to communicate this information between 2 nodes, so topics will going to handle the type of data that will transfer from one node to another node. That is what topics will be taken care, all this data handling thing. Okay, so it is not a separate program, so that when we are trying to create a node, so we will only define how the data needs to be communicated to the external world. Okay, so we will going to give a separate name for that to handle that data. So that is what we call it as a topic. So that will also, you're going to create a separate set of programs also going forward. So today the session is only restricted to create up to a node by creating a workspace. Okay, so once you know how to create a node, later you can kickstart to create even topics also, and making that particular node as a publisher as well as a subscriber. I hope I have answered you. Okay, so immediately I cannot show you how to create a topic, because basic thing only we have not learned how to walk. So then we'll start to learn how to run.
Okay, no.
Is
Sir,
it,
just
sir?
only one doubt.
Yes,
that
sir.
you see, we are telling there is a one topic, it can connect 2 nodes.
Yes.
Now, can we have more than one topic between 2 nodes?
Definitely, sir. It's a really valid question at this point of time. See, one example in the previous, when I displayed the graph for this TurtleBot and as well as TurtleSim teleoperation executable, you might have saw that only one node has been connected to various topics. Similarly, here on the other side also, the same node is also connected to various topics. In the same way, multiple nodes can connect to single topics also. Single node can connect to multiple topics also. Okay, the respective topics will handle different types of data.
Okay, okay. Thank you.
Okay, so fine, sir. So let me move on. So now very importantly, so to start to create these nodes, okay, so very first thing is we need to create a workspace. Okay, so what do you mean by this workspace? Very important. So workspace is nothing but a structured way of creating ROS2 files, especially. Okay, so once you create this workspace, you can create your own executables under this workspace. It is nothing but a simple folder. So now we'll try to create a workspace. Now to create this workspace, very important thing is we need to install a build tool. Okay, so this build tool name is called as Qualcomm. Okay, so I'll share my presentation slide. Okay, so just a minute. So I hope screen is visible. So very importantly, to create a workspace, so you need to install this build tool called Qualcomm. Okay, so this is a standard name under ROS2. That is what in ROS1, the same build tool, we call it as Catkin. So in ROS2, we call it as Qualcomm. So to install this build tool, we are using this particular command. Okay, I'll share this, I'll copy this and I'll share it in the command line, your chat box. So I request you to install this. Before installing this, I want you to update your entire system. Okay, let me go back to the Linux system now. I'm sharing VirtualBox. Okay, so before run that command, so please update your system, sudo apt update. Okay, so this is what the standard command in Linux to update your Linux system. So it will be asking your login password. So give that. Okay, so it will get update if there is any updation pending. Okay, so once it is done, so you can run this command to install the ROS, to install the build tool for Qualcomm. I think it is taking time. So I request everyone to follow and so try to update your system. Yeah, my system is up to date. All packages have got updated. So once again, I reiterate, I'm using Ubuntu 22.04. Have installed ROS2 Humble. And so I have updated my system to install the builds. I'm just pasting the same command. So you guys, everyone can copy and paste this and press enter. Okay, already have installed this. So that's why it is showed already installed. So for the people who are freshly or installing, it will also ask you to prompt to press Y or to enter Y or yes or no. So please try to give yes or no. So then this Qualcomm build tool will get installed here. Okay, so this is very, very important to create a ROS2 workspace. Yeah, I hope everybody done this. I request you to give thumbs up if it is done so far. Okay, thank you. Thanks for the acknowledgement. So now next is, see, previously you just observed whenever I'm typing ROS2 commands. So when I use ROS2 run, okay, so rather than completely typing this commands, if I use tab, okay, 2 times, so automatically it will auto complete the entire commands. Okay, so it is once you install this ROS2, automatically this auto completion feature is also installed. But for this Qualcomm build, which we have just installed now, so for this auto completion, we need to explicitly we need to install and then we need to source that particular bash file. So this bash file will be available in this location. I would like to navigate where this bash file is located. So this bash file is very, very important, especially whenever you are using any command related to the Qualcomm build. Okay, because we going forward, we need to build our own packages. We definitely will be using this Qualcomm build tools. Okay, so just to avoid typo, So we need to have this auto completion bash file. So that needs to be added to our bash RC file, and we need to source it. Okay, so I wanted to show you where this auto completion bash file related to this callcon is located. I'm just navigating that, so just follow it. I'll just share that link also. So how to source this? Okay, so CD, this particular file is available under this file location, folder location. So user share, okay, and it is available callcon underscore or complete. So there is one more folder called hook. Okay, so if I just enter and if you just list all the files, and you can see this is what the bash file, which is very much important, especially when you try to use the auto completion for this callcon build tool. Okay, so we need to source this. So as we did it for the environment setup, once you install the ROS2, so and added that source entire path into bash RC, the same way we all need to link this file into the bash RC as well. So I'm just trying to source this callcon bash file. Okay, so this needs to be added into bash RC file. Let me open bash RC file again. In my another terminal, I'm just using gedit. Okay, so use tilde / bash RC. So you can just open with that bash RC file. So this auto completion script needs to be added here at the bottom. Okay, I'm just adding here. I'll just copy this source and the path for this entire script file that is available. I'll just copy and paste it. I hope you guys, everyone are following, and followed by this script file, auto completion script file.
Sir?
Yes, tell me, sir.
For the user, we need double / or single will be good?
A single / sorry, it's
yeah,
single / one. Save this and close this. So whenever you update bash RC file, so how many whatever the terminals you have opened, in each and every terminal you need to source that, even that bash RC file as well. So I'll just come out of this, come to the root folder. I'll just source here, source bash RC file. So this will also give you, if whatever the path you have sourced here, the script file, if there is any wrong in the path given in this bash RC file, it will only give error if there is any mistake. If not, so it will execute, you will not get any output. So bash RC, so you can see, I think so successfully updated. So if you don't want to do this, just close the terminals and then reopen automatically from the backend. The bash RC file will open. Yeah, sir, it is initially it is quite difficult to follow. So try to follow this. I'll just repeat. I'll share the PPT also. So everything is mentioned here in the PPT. Okay, so no need to be worried. Okay, moving forward now, we just installed the build files, the build tool callcon, and we have also linked the auto completion thing. And now let us try to create the workspace. Okay, so this is what the basic thing, very important thing, and this will be the foundation for any of the projects that you're going to create going forward. So this is the basic thing. So that's why if you have any questions, please interrupt me in the middle, and so I'll try to answer the questions. Okay, so very important now. So let us try to create the workspace. As I mentioned, workspace is nothing but it's just a folder. Okay, so now I'm trying to create. So in order to create a folder, so I'm there at the root folder, and let me list the folder I already created for my purpose here. I'm creating one more folder here. So to create, you need to use once again command Linux commands, make directory mkdir is the command, then followed by the folder name. So whatever the folder name you wish to create, so try to create that. I'll be using ROS2 _ demo. So this is what the folder name I'm creating for this session. Okay, so if you just mkdir will create the new folder. So if you want to see whether it is created or not, just once again list all the folder. So now already this ROS2 _ demo folder got created. Okay, I hope you guys everyone are following. So I'm just copying this and then pasting. copy and then pasting in the chat box. So try to follow. So now, so get inside, change the directory to the newly created ROS2 workspace, that is ROS2 demo. Okay, so now next thing is you need to create one more folder called as source folder. So this is very, very important. The earlier folder name called as workspace folder, you can give any name you want, but the folder now you are trying to create, you should create as it is, which I am mentioning now. So create one more folder, use the same command mkdir, make directory. So the folder name will be source folder and the short form is src. The name should be as it is. Why? Because the callcon build use try to fetch this folder name itself from the backend if you want to create a new package. So that's the reason you have to use the same folder name. Okay, so folder got created here, source. Okay, inside the workspace called as ROS2_demo. I hope everyone are following. So please raise your hands if you're unable to follow. Okay, so now what this source will do, any file or any node. Yes, Professor Pawan, you can ask questions. Hello. Okay, so any file that you create, any package you create, any node that you create, so that you'll be creating inside this source folder itself. So that is why you need to create this particular folder inside the workspace. Okay, so I'll also show you the folder structure, so how it got created later, and very importantly, how this folder will be able to execute. Okay, so whenever you create any node, so node is nothing but, once again, it's a ROS2 program itself. Okay, so this ROS2 program will always try to use the global ROS2 installation. Already we have installed ROS2 globally. Now whatever the file as in the name of a node you're going to create inside this source folder, it will be using the custom nodes and the packages that has been installed by the global installations of ROS2, and using that, and it will try to create an this workspace acts as an overlay on top of the global ROS2 installation. So this is how you can execute any ROS2 programs that you're going to create inside this source file. So it is not a standalone or independent file. So it will be using the global ROS2 packages, the nodes, custom nodes, which is already installed when you are installing ROS2. So this workspace just acts as an overlay on top of this ROS2 global installation. Okay, so now already we have installed the build system, that is callcon. So let us try to use that build system now. So once you create this folder, two folder means I have created two folders now. One is workspace folder called as ROS2 demo. Another one is source inside that ROS2 demo. So now you be inside this workspace itself. Let us not go inside the source folder. Now use this command called callcon build, COLCON, callcon BUILD build. Okay, so try to run this. Okay, so this will try to create the actual executable folders inside the workspace. Okay, so enter callcon space build, enter, and you can see there is also a notification here. So build is successful, but 0 packages because I have not created any program inside this source folder. Okay, and now if I try to list the set of folders inside this workspace, you can see apart from source, by running this callcon build command, so I think 3 more folders got created called build, install, and log. Okay, so whenever you create any program inside this folder, so it will, once you build using this callcon build packages, okay, so it will try to build and also install the created packages and also create the log files inside the respective folders here. So that is what, and you can also navigate inside this install. Okay, so cd install file, and you can see if you list the files, you can see a lot of files got created. And very importantly, so this setup dot bash is very, very important, and you need to source this bash file. Okay, and so every time you cannot source once, each time you try to modify any of the source files that are that has been modified inside the node or whatever the program you create. So every time you need to source this bash file, this script file. So rather than that, once again follow the same step. Okay, open gedit, add this path for the script file into the bash RC file. So there's one more last addition you need to
sir.
do. Yes.
Like this gedit bash rc is for like the things which I have to use regularly, but the
Yes.
folder we made, that ROS2 demo, is considered one project, right?
Correct. It's
It
a
will continue for like a,
it's a one project. For example, Workspace is nothing but assuming that you are working, multiple people are working on the
yes,
same project. For example, one person is working on actuator side, another person working on 3D camera, another person is working on LiDAR. So now you want to share this entire project, right? Rather than sharing the
yes.
entire file system, you can just share this Workspace. That's it. So this is how it acts.
So my question main is like the bash rc is so that I do not have to source it every time I open a new terminal.
Correct.
But my project can be changed. So every time I have to go and change the source code in the bash rc, depending on my project.
Yeah, definitely. See, whatever the updations you do, right? See,
Yes.
for example, this is very, very important. See, now I have created a workspace called as ROS2 demo. Assume that you have created one more workspace with different name. Okay, so once you build this particular workspace, whatever the script that has been created inside this install folder, that needs to be sourced inside bash rc.
Okay.
That is for one time only. That is for one time. So this is the basic initial setup. Once you create the workspace, these are the prescribed things you need to do. Otherwise, you cannot run the node, whatever the nodes that have showed in the demo examples, right? That you cannot run. Okay.
Okay.
So, yeah. So follow this the same
sir.
link. So tilde / ROS2 demo. I'll just copy this. So paste this / setup.bash. Save this. And I think something got wrong. Yeah. Save this and then.
શું છે કુલચા છે ને મારા બનાવીને મૂકી જ દો, હું હમણાં ખાઈ લઉં છું. કેમનું થોડુંક મારે આમાં ધ્યાન આપવું પડશે.
I'm just verifying whether the link is proper or not.
ખાઈ લઈશ આજે.
Yeah. So whatever the link I have just created now inside the bash rc, it is proper. I think I didn't get any error messages now. Okay. So this is what each time whenever you create a workspace, so you need to source that installation script file, that is setup.bash, which is available inside the install folder. And you need to source that entire path in the bash rc file. Okay. So this is the first step you are trying to do now. So far, we just created only the workspace and you have just created a folder and we have already built. We have not created any package so far. So the next step is let us try to build a package. Let us try to create a package. Okay. So in order to create a package, as I already mentioned, or everything, any files that we will want to create as a node or a package, that will be creating inside this source folder itself. So I want you to navigate inside that source folder. Okay, I just came one step back from the install folder. Okay, so I'm just moving inside, change directory to source. Okay, so far the folder is empty. So now I'm creating the package inside this source folder. So to create this package, I'll be using ROS2 command. So follow my command, ROS2. So to create a package, the short form is pkg, package space create. Okay, and you have to give the name of the package. So name of the package, now currently I'm using standard name, my robot controller. You can give any name, whichever you want. Okay, so followed by, so what type of package you are trying to create, whether it is a C++ package or Python package, you need to mention here. Okay, that is what the next attribute for this command you need to give. So I'll be using build. I'm just typing just build. I'm just pressing the tab 2 times, so it is auto completing the command build type. So this will try to avoid the typos. So I'll be using services called as ament_python. So what are the type of services that are available to create the packages? I'll just try to type 2 times tab. You can see here. So if you want to create a C++ package, you can use ament_cmake. If you want to create Python package, you can use this ament_python. So now Qualcomm build tool will use this services to create the packages. So respective packages, whether it is C++, whether it is a Python package. So that is what. So now this is the standard service that is available, ament_Python. Okay, so and then followed by, if there is any dependencies, you can use so double hyphen, so dependencies. So this is the command. I'll just copy this and paste it in the chat box also. So followed by the dependency, what you are using is RCLPy. Okay, so this is the standard ROS Python library that we will be using whenever we create any node. Okay, so that dependency we are trying to use while we are creating the ROS2 package. And if you're trying to use, if you are using ament_CMake services, then it will be, instead of ROS RCLPy, it will be RCLCPP. Okay, that's it. Okay, so now press enter. Okay, so you can see there are some logs that has been created. I hope everybody are following. I'll just copy this entire command and I'll paste it in the chat. Please follow and try to use this. Okay, so this is got successfully created. So that's why you can see a lot of logs here. So now earlier there were nothing inside the source file. Now if I try to find the list, all the files and folders, you can see this is the package that got created inside this my robot controller. So this is what the package now, based on my command line, in the command line which I'm used, my robot controller, and it is a Python package. And you can go inside this package also, and if you just list, you can see one more folder. Okay, and you can see the setup.py and package.xml. Okay, so now on, I'll try to use an editor, whichever the editor you can use. Even you can use the normal text editor also. I'm very fond of using VS Code. So if you are not installed any VS Code, you can use you can install VS Code now itself. And so let me go back one step. Okay, so I wanted you to show the folder structure that got created inside this workspace called as ROS2_demo. So I have just created a package, okay, inside the source folder. So the package name is called as myrobot_controller. So once I create this package, which is a Python package, and including the dependencies I have created, these are the list of files that got created. Okay, so from now on we can use editors. Okay, so I'll be using VS Code. So you can use this simple command if you have not installed any VS Code. Okay, so I'll just copy and paste it in the chat box. Okay, so use this sudo snap install code classic. Okay, use this. I already installed this particular VS Code, and once you open this, I can also show you to install the dependencies also, so where you can completely convert the existing editor into an IDE. Okay, so run this command, so to install the editor, VS Code editor. Okay, so already have installed. So let me run the code to open the editor. So I'm using the command called code space dot. Okay, so once I run this command, so automatically under this folder structure only, the VS Code editor will get open, and you can see whatever the workspace. Under that workspace, you have a folder called source. Okay, inside this folder, you can see all the files that are listed. I think it is getting loaded.
Hello, sir.
Yes. Tell me.
Why we need to build Qualcomm build, sir? Why we have to do?
No, that
What
is a
happens
build
if we
tool.
do?
No, once you build that, so see, when you write a simple program, any program, whether it is a C++ or C program or a Python program, okay, how you run that program? You have a set of commands to run it, right? So there is a set of files that get created. So it will first, it will before creating the actual executable file, so it will .obj file will get created, and then later executable file will get created, because so it needs to include all the libraries, any extra functions or methods that has been included, everything. So in the same way, so whenever you create a node, okay, So to build that particular node, so we are using the build tool called as callcon. Okay, so to create the executable of the same node, okay, we are using the build tool called callcon. Got it? So that's why while creating the workspace, I've just showed you without creating any files. I've just showed you the folder structures. So once you run this callcon build, so you have saw the list of folders got created, including log folder, install folder, and build folder that got created. Okay, so now once that got created, that's why even I've added that script also, the setup.bash into bash rc file also. So whenever you run, whenever you create any package, so automatically when you run the build callcon build, so it will create the nodes executable or any package executable file that is available inside that build file. Got it?
Yes, sir. Got it, sir.
Okay, so it is just like, so when you create a code, so when you try to use it as a software, you need to create an executable format of the same. So callcon build will helps to achieve that for the creation of that executable. That's it.
Yeah,
Okay,
got it, sir.
so yeah, this is what. So under source, you can see my robot is the package that I have created. Inside this, you can see one more folder with the same name, and you can see there is a package.xml that got created. And these are very, very important. So I hope time is running, 3 minutes more. So I think I need another 15 minutes to complete this. I hope everybody will bear. Okay, so package.xml, you can see this is the information where the versions, and if you want to publish this into the GitHub, all the details, repository details related to the owner of the creator, so that will be information. That information is available. You can see also RCL here. So this is what the dependencies that are used. Okay, so while creating the package, similarly setup.py is also similar kind of file. The same kind of information is also available here as well. I think my system is taking time.
So, sir, the setup.py and the package.xml are considered as a identity of the topic, right?
Not the identity. These are the list of files that got created. Okay, so
Okay.
all the files are very, very important. So it has their own prominence. Okay, especially in creating the respective executables.
And if let's say suppose I made uh, the package with RCLPY, and then I found out that I need more 2 or 3 more dependencies in it, then I have to
Yes.
also add it in this one.
Definitely. So while creating the package only, whichever the dependencies you wanted to add, you can add it directly.
Okay, sir.
Okay. So for the sake of this particular part, just to create a node, a simple node, I've just used only the RCLPy. So that is what the only library I'm using currently to create a node.
Okay, sir.
Okay, I'm just resharing. So this is what inside the setup.py, you can see the package name, which I have created. And there are other information, versions. So you can do means version control software if you are using. So these are an important thing. And very important here, entry points. So this console script I'll be using. So whenever I create a package, okay, because you saw that when you run the rqt_graph, okay, so you saw the name of the node, everything. So you will be creating the actual node name, and then you'll be linking to the actual file system here. So whenever you create a ROS2 nodes, okay, that is what you will be creating here. Okay, so now any node that you're going to create, that you'll be creating inside this one more folder, which is of the same name of the package called my_robot_ controller here. So inside this only you'll be creating the file. Okay, that is what now we will be doing it. So I'll just closing that, it is taking time. Okay, so I'll just close this. So we'll go back to the next step. Till now, I think so far so good. I hope so. So any questions?
No, sir.
Okay, great. So let me close this. I think it's taking time. Yeah. So now, once again, clear this. So we have just created the package and go back to the workspace folder hierarchy. So I'll just go back one step back. I'll just use cd space double dots. Okay, so here you can see the source folder, build folder, install and lock folder. Once again, I'll try to run callcon build. Okay, because already I have created the package inside that source folder. So I'm just once again trying to run this build. So every time you create a new file, try to use this command callcon build to create the executable. Okay, so now it is taking more time now compared to the previous one. And let's see, do I get any error or warnings? So I request you guys also to follow. So yeah, you can see here summary, one package got created, executable of this package got created, and you can have even you have seen the notification. So now if you go inside the install folder, you can see. Okay, so you can see the my robot controller executable got created inside this. Simple. So that is why we are using callcon build command. If you are getting any warnings, so please let me know. Okay, so I'll try to resolve it. Okay. So now moving forward. So now let us try to create a file. So far we have understood how to create a workspace and how to install the essential build tools for ROS2, that is callcon build tool, and also we have created a package, and we have created a Python package now. So now the next step, very important step, the last step, how to create a node. Okay, so that's the reason why I have created the editor. So I installed the editor. So we'll use the editor itself to create a file. So before that, so let us try to create a file and then open the editor, and then let us start to create a node program for our node. Okay, I hope everyone are following. So now, as I mentioned earlier, whatever the files you need to create, that needs to be created inside the source folder itself. Okay, so let me go back to that source folder, cd source. Okay, so inside my package that I have created, my robot. Okay, there is one more folder with the same name called as my robot controller. So get into that, and currently the one file which is available is init_.py. Okay, so now here we are creating the file, Python file, so which is a node program. So this is what the ROS2 node is all about. Okay, so any idea what do you mean by ROS2 node? So as I already mentioned, it is just a program, a ROS2 program, so that will interact with the globally installed ROS2 communication packages and tools. That's it. Okay, so it will try to use all the functionalities, okay, and even standard nodes that already been installed when you are installing the ROS2. Using that, so we can create, because while creating the node, you will come to know what are all the libraries that we'll be using to create that. So that is what the main thing is. So I'll just try to create a file here. I'm using a simple command called touch to create a file. Okay, so I'm just creating my first node. So let the name be first node itself, first node.py. Okay, so if I list it, already this got created, this Python file got created. So let us convert this into executable format. So change the mode of this file. Okay, so I'm using this command. I'm just copying this and then pasting it in the chat box. Okay, so touch is the command to create a file. So you can use nano also. So these are all the inbuilt functions that means tools that are available to create a file. So Python file with an extension .py I have created. Convert this created file into executable one. So I'm using the command to change the mode of this particular file. So chmod, change mode, plus xx is called executable with the same file name, first node. Okay, so enter. So the mode of this file got changed into executable format. Now if you just type, if you try to list, you can see the color of this file got changed. Earlier it was just a file, now it has become executable file. So this is the first step you need to do once you to create a node. So any questions so far?
Sir, hello, sir. 1 minute.
Yes, yes.
Now, you see, in the starting, when we tested the ROS2 condition, whether it is installed or not, at the time
Okay.
we are tested with the 2 node with the 2 different terminal. Now,
Correct.
Now, what is the difference between that node and this node? I am not exactly getting that.
Sir, both are same, sir. See, now it is that node has already been created during the installation only. That has been created. Okay, that is also a node. That node is now working as one node was working as a publisher. Another node was working as a subscriber. Now you're not creating any subscriber or publisher node. You're just creating a node. Simple. That's it. Okay, so what this node is, a node is just a Python script. If it is a Python package, if it is a C++ package, it is a C++ program. That's it.
Now, for example, in the controller, we can have like a different types of serial protocol, like a serial communication, like a I2C, like a SP, like different things. So that through one communication, we are trying to transfer some data. Is it like that? Same? Is it this one? Can you consider like that?
Sir, that is protocols. What you have told, those are all protocols.
Yes.
See, this is a simple program you are trying to create, whatever the activities you need to create. For example, now once I run that talker node, if I run the talker node, that particular node functionality is to publish some information. That information is what? Hello world. Okay. Understanding. So in the same way, assuming that in the real robot, now we have integrated a sensor. Take an example of a distance sensor. So now distance sensor, you need to, it will be always try to publish the data, correct, right? So to publish that data, you need to create a program to receive that. Why? Because it will be, you'll be getting a raw data directly. Ultrasound sensor, as an example, it will not directly push you the distance. It will be some digital format, correct? You have to receive the actual data and you need to modify it. And then to receive that data, you need to create a node. Now, actual hardware that has been created. Now that particular node program, it will read the data, it will calculate, it will manipulate the data, and it will publish the data as a distance. Simple. So this is one example where that node will be used. Similarly, so based on this node, now I want to create an obstacle avoidance robot. Okay, so with the help of this node, where it will try to receive the data from the real hardware sensor, and then this particular node is able to generate the distance information. This distance information is pushed to another node. Okay, so in order to push to another node, it should push through a topic. As we just discussed, since we have not even came to how to create topics at all. So first node which you have created to read the data of ultrasound, it should be publish the data. It should be a publisher node, and this particular node should send a data to actuate the motors. So now to control the motor, you need to create one more program. So that will be another node program. Okay, so this another node program will receive the distance information from the ultrasound sensor node program. So based on the data, so this listener node, which is a motor program, so it will actuate your motors. Simple. I hope now you got the idea, visualization, how this will work. Got it, right?
Okay.
So now going forward, I'll just have created this first node, and we have converted that into executable format. So now I'll go back to the source folder itself. I'll be using cd change directory to this level, source level. So that's why I'm using 2 times double quotes, dots /. It will come back to the source file, source folder level, and then I'll be using VS Code command to launch the VS Code editor. I think it will take time to launch. Okay, now if you see the folder structure inside the package called my robot underscore controller, you can see one more folder called my robot underscore controller. Inside this, we have created a file called as first underscore node.py. Okay, so from here on, we will be creating a basic skeleton. So how each and every node should have. So upon that, so we'll be trying to write one node program, and then we will conclude this session. Okay, I'm just closing all these things as of now. Okay, so if you see here, this folder structure. So this is what under the workspace. Inside this workspace, there is a inside this workspace, there is a folder called source. Inside this source, you can see this folder structure, and inside this folder, same name of the package. So there is a file called as first node. So open this file, and so now we are writing the program inside this. Okay, so I'll display the basic Python skeleton. Very importantly, I'll just go back to my slide now. So I think everybody can take a snap of this. I'll just stop share and reshare. Okay. So basic thing is, once you open this particular file, it's an empty file. So very importantly, first you need to add an interpreter line. In the line 1 itself, you need to add an interpreter line. That is what this line is all about. So Python is already installed when you install Ubuntu. So Python 3 is already installed in your system. It is available in this path. So you need to include this interpreter path into your file. So the node file that just now you have created there. Similarly, you need to import this library rcl.py. So this is what the dependency we have included while creating the package. So this we have to include while creating the node. And to make your Visual Code as an integrated development environment, so IDE, so you can install the extensions. So especially for auto completions, already I have created this inside in my installation. So you can do that. And this is the basic skeleton program for any node. And if you see here, I have included the interpreter link, path link. Similarly, I have included the library for RCL-Py, and we have created a main program here. Okay, so with a separate function or a method, so called name. And so this particular part is this is a standard Python skeleton. So whenever you're trying to execute this particular Python program through a terminal, so this is the default methodology you'll try to include in your program. So that's why, so main function you're trying to, whenever you're trying to execute to the terminal window, so you'll be creating a separate main function here, and with an arguments, if there is any optional argument, you'll be passing it, otherwise you're not passing it. So there are two commands, very important commands I have included here. So before creating a node, but this is not the actual node. So related to that node, so there are some more commands that will come inside this main function. Okay, and very importantly, ROS2 program, especially when you're creating any node, it follows the class and object concepts of Python. So very important. So you should be well versed with the concept of these classes and objects and the concept of inheritance, very importantly. So in order to create any node program or any set of nodes. Okay, so that is what. So very importantly, so I'm using this RCL-Py package. Okay, so library, and I need to initiate so this particular package. So that's why I'm using this init function. Okay, so I'm passing the arguments when I'm trying to call the main function. Inside this, the same arguments I'm passing. So now once I run this main function, I need to shut down this. Okay, so that's why I'm using .shutdown method under RCL-Py method. Okay, so this is the basic skeleton that you need to include in any of the node once you start to create a Python ROS2 node. Okay, so you can take a snapshot. So try to create this particular program inside your first node program. So I'll be resharing my Ubuntu system screen. Okay, so now you can.
Sir,
Yes.
the snapshot you showed is like the basic to basic skeleton, right?
Yes, very basic skeleton,
like,
and mandatory skeleton that need to be included.
Yes, like, but if I'm building my own robot, I have some constraint in my mind. Like, how will I know that what should I write like in this?
See, any node you create, So this is the basic
Yes.
skeleton that you need to include in your node program.
Okay.
Got it?
Yes, sir.
Okay, fine. So I'm just importing. Okay, so I'm creating main function. Okay, so the standard structure I'm creating. I hope everyone are well versed with the basic Python classes and objects thing. So I'm unable to cover that in this session. I think already time is running away. Yeah, so save this. So I'm not using any as of now. So I'm trying to use the library rclpy.init. So try to copy as it is. Okay. So now you just created a simple basic skeleton. So now, as I said, so this entire ROS2 works on the concepts of objects and classes. So now I'm creating my first node. Okay, so this is the basic skeleton. So now actually I'm creating the node. So from now on, okay, so in order to create a node, I'm using the concept of classes. So to create a class, so we have to use the standard keyword called class. And so I'm creating my class name. I'll be using Pascal naming conventions. So try to follow this only. My node. Okay, I'm using the concept of inheritance here. Okay, so inheritance. So this particular package method will be available inside this RCL library. So I need to import it before to inherit the functionality of the node. Okay, so to create that particular path, so I'm using this command. So from rclpy dot node, I'm importing this method called node. So this is very important to while creating the node. Okay, so inside this library dot node, there is a method called node. I'm inheriting all the functionalities which is available inside the node while creating my node class. Okay, so colon. So you need to create a constructor. So to create a constructor, you need to use a magic method init. So and there should be one parameter inside this class constructor. So it is self, and very important, the first line inside this constructor will be the super. Okay, so follow as it is. I'll share this code also, snapshot. Okay, so this is the first node I've just created inside this class node. Okay, and so this will if you run the program, so it will not do nothing here because we are not displaying any information so far. So we'll try to print some information. So before that, in the main program. So we need to create an instance here. I'm creating a simple object called node itself. And so you know how to call the class. So my node, like how you call the functions. So my node. So that's it. So save this program and go back to the terminal. Okay, you can take the snapshot. Or otherwise what I will do, I'll just, I think whether I can copy it or not, let me see. Yeah, I think I can copy it. I've just copied and pasted this. Okay, so I'll just minimize this. So just to see, so whether this, because I have not built, I have not used the callcon build now. So we know already Python, it is an executable format, correct? So let me go inside this workspace, so which I have got created inside the source, and we have my robot controller. So inside this my robot controller, there is the same folder, and we have this executable. So let us run this file. So let's see what is the output we're going to get. Okay, so it's showing some error. Let me see what is that error. Okay. Save. Yeah. So one mistake I did it here was I should not give space inside this. So I have created my node. So the name of that node is my first node. Okay, inside this first line called super. So under this magic method. So this is not printing anything. So I've just executed this Python file. So whether any errors I'm going to get. So because when I call this particular file, so through this executable, when I run this executable file, so it called this particular main function, and it executed this particular instance. Okay. So now to print something, so let us include one more function here inside the class node itself, that too inside the constructor. Okay, so let us use this command. So let us use this self dot logger, get logger. I think my system is quite sluggish today. Okay, I hope everyone is following up. So this is what the information I'm trying to print. Yeah. So save this and try to execute this. Yeah, you can see here, including my timestamp, it is showing the node name of the node, and it is printing whatever the text that has been created under this command using this get logger function. So it is able to print. Okay, so I hope everyone have completed till here. Arpita ma'am, I think it's already 10 now. So can we conclude the session, or how it is?
Yes, sir, we'll do that.
We'll do that. I think so. Few more parts where I think I might have needed 15 more minutes. Maybe if possible tomorrow I'll join. I'll complete it if possible. I hope it's already 10. I've taken half an hour more. So any questions so far? I think I'm ready to answer.
It's really good, sir. We are given this very good demo. It's really good. So just sir, I want to know one thing. What's your technical background, sir? Education background? May I know this?
Sir, I'm from electronics background only. I've completed my master's under signal processing domain.
Okay, that is fine. Great, 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 great.
Yeah.
Okay.
Yes, yes. So I have built robots, have worked on actual practical applications on robotics itself, on R&D. So I think this is just a basics that what I'm trying to give you in a session. So if you try to implement using simple Raspberry Pi kit or even using Arduino or any open source platform, so you can build your simple two-wheel differential drive robots also using, you can run under ROS. Okay, so I think if you get a proper hands-on on this, how to use the actual commands, creating nodes and so on, and communicating between nodes, I think it will be the basic steps that you can jump into the real hardware and you can build the applications.
Yes, sir. In fact, I developed
Hello,
one
sir.
mobile robot cart that I've
Oh,
done
fine.
totally with help of the C++ and 8-bit microcontroller. So I want to go RS to ROS2. That's
ROS,
why
okay.
I just trying to learn. Thank you very much.
Great, sir. Tell me, sir, Mohan, sir.
Sir, I am working on mobile robots. So I have built a differential drive with an caster wheel, sir.
Okay.
So if you want to drive with a four-wheel drive, means on each wheel having each single motor, means four wheels. Can I
Okay.
run it on ROS2, sir? Is it possible?
Definitely, sir. Any type of motor. See, the thing is, what type of driving mechanism you are using. For example, if you are using four-wheel drive, so what kind of mechanism that also included, whether it is an Ackermann drive
Differential
system,
drive.
it is also differential drive. So if it is a
Yes,
fold,
sir.
okay,
I have
definitely.
created two differential drive for each one, sir. Yeah,
So
two differential drives.
if it is a four-wheel drive robot, sir, the main thing is how you maneuver the robot, especially on the floor. Okay, so if you are using mechanism wheel system, I think definitely you can have omnidirectional robot system. That is one of the advantage. So otherwise, you have to go ahead with, especially maneuvering part, you have to go for Ackermann steering system.
Actually, I have implemented, sir, but the turning is not taking very smoothly, sir, as expected. It is not
Okay.
taking properly. So,
Okay.
means wheels are rotating opposite directions, but not taking properly. So that is the issue. So you said that mechanism wheels. Maybe
mechanism is
it will
one
help.
possible thing. Yeah, you can. There are a lot of video tutorials available on mechanism wheel part, how to implement the thing. It's one of the indoor robot means that mechanism wheel use that's on the smooth floor, especially not on the off-road type of system. If it is a smooth flooring system, so definitely mechanism wheel will achieve the expected maneuverability.
What about off-road, sir? In off-road, which wheels?
Off-road, it's better system is Ackermann system only. It is better.
System. Okay.
Why?
Sir.
Because maneuvering is main
Yeah,
thing,
okay.
no, sir. That is the main thing. See, you can have a separate servo-controlled steering mechanism for all the four wheels. Okay, for example, you can turn completely. You can maneuver 90-degree itself sideways, even with that system also. So how means the mechanical design that what you implement in the robot while building the robot, that matters.
Oh, okay, sir. Yeah, okay, sir. Sir, I have many doubts, so I can continue in personally, sir.
Sure.
Can I?
Definitely.
Thank you, sir. Thank you, sir. Thank you so much.
Yeah, thank you very much. Thanks for your patience. I think so. I think it took almost 2 hours to complete this session. So, okay. Yeah, proceed, sir. Kiran, sir.
No, sir. Not. I
Oh, you
can.
wanted to in touch with me personally. Okay, no problem.
Yeah.
Fine, ma'am. Over to you, Arpita, ma'am. I think you can
Sir,
give the conclusion.
yeah,
Yes, ma'am. Tell me, ma'am.
yeah, please go ahead, ma'am.
Yes. Sir, good evening, sir.
Good evening, ma'am.
Sir, is there any source to build a robot that can be used in underground water, sir?
Source in the sense, ma'am? Resources,
So,
sir?
yes, sir. As I'm a CSE student, I was unable to gather this sensors and all, sir?
Fine. I have not worked on the building it actually. So we have used the available robot which is there in the market. Okay, so not the programming part, only for the official purpose. Okay, so I'll try to fetch the sources and try to get to you, ma'am.
Thank you so much, sir. Thank you.
See, whatever may be the concept, whether it is underwater, whether it is aerial robots or land navigation robot, the concept is same. So there will be a sensor, there will be an actuator. So here on the land, it will be the actual motor. So in the water, it will be a propeller. Similarly, in the air also, it will be a propeller. Okay, so the actual actuation mechanism and then reading the sensor data, it's the main thing here.
Okay.
That's it.
Thank you, sir. Thank you so much.
Yes, ma'am. Over to you, ma'am.
Yeah. Thank you so much, sir, for conducting an excellent session on Linux and Linux for robotics and ROS2 basics. Hope as a practical approach and clear explanations provided you all with the valuable hands-on clarity essential for upcoming sessions. We are grateful to both the resource person for generously sharing their time, knowledge, and expertise, making today's sessions highly informative and engaging. We also appreciate all the participants for their active participation and enthusiastic involvement. We look forward to your continued participation in the upcoming sessions of this FDP. Thank you all. Have a pleasant evening. Thank you,
Thank you,
sir.
ma'am. Thank you,
Sir.
Thank you. Thank you very much, ma'am.
Thank you so much. Yeah.
Thank you all. Have a nice evening. Good night.
And we'll be sharing a feedback link in the WhatsApp group. Please do fill the feedback. It will be enabled only for 15 minutes. It hardly take 30 seconds to fill the feedback. We'll be sharing right now. Thank you all.
Yeah, my contact, I'm there in the group itself. I think you can take it from that group. That's it.
Yeah, I have added sir also in the group. So you can take it from the group.
Hello, organizer ma'am. Hello.
Yes, sir.
Can you share that PPT so that we can try to work tomorrow morning at like that, try to do this experiment. Is it possible?
Yeah, sure. Sure, sir. I'll collect it from the sir now. I'll share it with you all.
Thank you.
Madam, is it possible
Also,
to
we'll be
share recording also?
Yeah,
Maybe
we'll share the recording as well.
Yeah,
Soon
yeah.
after the completion of this session, we'll be getting the recordings. So we'll share the same thing with you all.
Yes,
Not to
ma'am.
worry, sir.
Yeah, thank you.
So once you, yeah, in the initial class, you might feel difficulty in following the commands and all. But as you practice for the upcoming sessions, it will be easy, sir. Only thing is you need to practice.
Yes, madam. Thank you.
Yeah. Okay, sir.
Fine. Thank you. Good night once again. Bye-bye.
Yeah, good night.